All right. So in this case, guys, we are going to consider our typical exam revision. So this is actually a full paper revision that we are going to work with for our mathematics N3. So this was actually written in November 2024. So guys, we're not gonna waste time. We want to quickly go through our questions, but as usual, make sure that you go through the instructions, the information that you are given, all right? Make sure that you go through the instructions and the information that you'll be given, especially I want us to check here, especially on this part, make sure everything, the questions may be answered in any order, all right? But keep subsections of questions together. That is, if you answer question 3, if you say you want to start with question 3, make sure that you answer everything for question 3, like making those subsections for question 3 together. If you're answering question 4, let it be like that. So you can answer in any manner that you want. Any question you can start with, all right? And also, here, all final answers must be accurately rounded off to 3 decimal places. So you're going to use 3 decimal places, and diagrams are not drawn to scale. And also take note on number 9, all graphs must be drawn in the answer book. A pencil may be used. So take note in the answer book. So we do not have a graph paper that we are going to use. We're just going to sketch them in our answer book as it is. All right, so this is it, guys. Make sure you go through your instructions. Each and every part is important. So not wasting our time, let us quickly go through our questions. On question number 1.1, you're given factorize the following as far as possible, in prime factors. As you are factorizing this, you're supposed to have this in what? Prime factors. Remember the factorization of the quadratic expressions. So this one, it is just a disguised quadratic expression. It is a quadratic expression, but they are disguising it. How are they disguising this, guys? All right, let's see. This is 3x squared plus 7x to the exponent of 2. All right, minus, this is 4 into, take note, we've got 3x squared plus 7x again, minus 12. This is what we have. And the question is, you're supposed to factorize as far as possible, meaning to say factorize fully, factorize completely. That is why you see I've got 6 marks there. You're wondering, 6 marks for this? What is happening? Okay. If we are to consider our question, like I said, this is just a disguised quadratic equation, because quadratic expression that we have. If we consider here the 3x squared plus 7x, this part, 3x squared plus 7x, it is the same thing. It is the same part. So since this is much complicated to work with, of which, guys, if you understand your factorization, since the coefficient here is 1, you just know that you're going to have what? 2 brackets. This is just like x, to say this is x. So if you're given x squared, how do you write? You're supposed to write x here and write x. But in our case, we are not going to write x because we have this as an expression, 3x squared plus 7x. Also here, we are going to have what? 3x squared plus 7x. Representing what? Representing the part of what? This is the part of x. Then we know that we were going to deal with what? The constant. What is our constant there? Minus 12. We know that we need the factors of minus 12, but these factors must add up to what? Negative 4. As we do understand our factorization, when this coefficient here is what? Is 1. Because the quadratic. Just that it's hidden in these, also part of a quadratic again. So what are the factors, guys? The products that we take two numbers, we multiply two numbers, we obtain minus 12. From the two numbers, if we add them, we must get a minus 4. So from minus 12, we are going to definitely think about a 6 and a 2 to get this and a 4 there. We can see that if one of these is negative, a 4 can be obtained. I mean, a minus 4. If one of these is what? Negative. Either 6 is negative or the 2 is negative. If you multiply, you get minus 12. If you multiply here, you get minus 12. But which part? Now, when we add like this, we are going to obtain a minus 4. When we add, that is on what? Minus 6 and 2. Minus 6 plus 2, that's 4. So you're going to have what? Minus 6 here and what? A plus 2. Then you factorize this. Again, because you can see that is a quadratic. So that is the case, guys, that you are supposed to simply have. But let's say you do not understand because of this part where we have got the 3x squared, this and that. We can try work it in our own understanding. Let introducing k in place of what? In place of that quadratic that we are seeing there. This one, 3x squared plus 7x, one that is the same. So we can just say let k be equal to what? 3x squared plus 7x. So meaning to say, in place of this, where I see the 3x squared plus 7x, I'm going to put what? A k. So here it's what? Squared. So that's k squared. Minus 4 into this bracket, which is the same part here, which represents what? Which is now represented by a k. So that's minus 4k minus 12. We do not have that part here on what? On 12. So the minus 12 remains as it is. You are used when you are given something like this to factorize. So from there, you are going to factorize the way that you are used to in terms of k. This is the same part. This is k squared. Remember, the coefficient is what? Is 1. So you're going to have k here, going to have k here. Just like the previous case, guys, the factors or the products of what? Minus 12. But these products must add up to what? Negative 4. We saw that it's negative 2 and what? Sorry, negative 6 and 2. This one is not going to change. Negative 6 and what? And 2. But remember, this is not a factorization for k where you're going to leave your answer like this and you underline to say it's done. No. Remember, we introduced, we said, let k be this. It is us who have to introduce this part. So we must bring back the k, I mean the x, yeah, the part of x in place of what? In place of k. So it will be what? This one, which is 3x squared plus 7x minus 6. Here. We do the same thing in place of k. We substitute the 3x squared plus 7x, 3x squared plus 7x plus what? Plus the 2 that is here, plus the 2. So this is exactly what we had here. These are the exact brackets that we had. So as we can see, guys, factorization, it lies in your hands. It is in your hands. So for you to have these two brackets here, the two brackets that are indicated here, it is either you're going to simply have them direct by understanding your factorization concept, or you are going to use this concept. Still, you're going to have these two brackets. But after, like I said, they are saying here, factorize as far as possible. Is this as far as possible? Is it fully factorized? We are supposed to take our numbers now aside and factorize, these terms aside, expression that we have here. Factorize again. 3x squared plus 7x minus 6. Can we factorize this? Are we able to factorize this? All right. Remember, in our factorization, guys, when the coefficient of x squared is no longer 1, in that case, guys, I want you to use any method that you are used to. Any. This is factorization. There are so many methods. There are also the cheat methods which can be used to cheat these quadratic expressions. All right. But what we can simply do is to multiply the first term to the last term when the coefficient of x squared is no longer a 1 like this. So you multiply these two. 3 times negative 6, that's negative 18. So we are going to have negative 18 x squared. So what you're going to do is to ask yourself the factors. Remember I said you need the factors of this, the products of minus 18x squared. Just like the previous case, two numbers that you multiply, but this time they must give you minus 18x squared. And they must add up to the middle term, this one. They must add up to 7x. So do we have two numbers that we multiply? The two numbers, we get minus 18. But when we add them, we must get what? Positive 7x. So minus 18, guys, we can see there's something about a 9 and a 2 there. There's something about a 9 and a 2. So to obtain a negative 18, one of these must be negative. Negative 9x, or we can have it as positive 9x and negative 2x. One of these must be what? Negative for us to have this. But when we add now, which part are we going to have exactly this part in the middle term, 7x? When we add, if we add these two, minus 9 plus 2, that's minus 7. 9 plus minus 2, that's positive 7. So this is the one that we need, which gives us exactly part of the middle term. So guys, take note, when the coefficient of x squared is not 1, we have to go through this longer way. Like I said, there are so many ways, the cheat methods on how to factorize. So you can, guys, go through the videos, check how to factorize. What you just need there are two brackets from this, all right? So using this method, we are going to substitute those factors that we said they are the ones which represent what? The middle term. So we're going to substitute them in place of the middle term. You put them there in place of the middle term. So that's 9x minus 2x as they are in place of the middle term, minus 6. So as we can see, guys, we have got 4 terms now. This is factorization of our N2 mathematics when we've got 4 terms grouping into 2. So you can factor out the highest common factor between the two, which is 3 and 9 is going to be 3. That's 3x. 3x squared divided to 3x, that was going to give you x. 9x divided to 3x, it was going to give us positive 3. 9x over 3x, just going to cancel. And this is a 3. So whatever that you have obtained in the first bracket, this one is supposed to be the same as what you're going to have from these two. So when you factor out from the remaining part, you are being limited now. Your answer is limited to, it must be the same as this. So what are we going to factor out? Is it going to be positive 2 or it's negative 2? So you test your numbers. Minus 2. If we put a minus 2, as you can see, guys, minus 2 is going to give us positive. Minus, minus, it's positive. Minus, minus, it's positive. But if we were to put a positive 2, minus and a positive, it's a minus. Minus and a positive, it's a minus. So these brackets were not going to be the same. We need a part where the brackets will be exactly the same. So minus 2x divided to minus 2, that's positive x. Minus 6 to minus 2, that's a positive 3. So as we can see, the two brackets are exactly the same. So this part, we can factor out that common bracket, x plus 3, which is common. If we take out this bracket here of x plus 3, what are we going to remain with? Here, we are going to remain with what? 3x. What about here? What are you going to remain with? A minus 2. So these are the two brackets that I said we need. From your own technique of factorization, guys, you're supposed to have these two brackets like this. Either you're starting with this one with a negative, followed with this one with a positive. That one does not affect, you see. So guys, they will be testing all this. So we are going to have x plus 3, right, into 3x minus 2. So this is for this bracket. It gave us what? These two brackets. In the same manner, this is a quadratic expression, guys. So definitely we are going to have what? Two brackets again from this. Using the same technique of your factorization or whatever that you have there. You're supposed to have what? Two brackets from there. So this is it, guys. So using the same way, or you can even try another way, guys. There are so many ways on how to do this. All right, so let me not confuse you. Let me just continue that method. Like I said, you multiply first and last. 3 times 2, that's 6x squared. Then you look for the factors of 6x squared. But these factors must add up to 7x. So do we have two numbers? You multiply 2 terms, you get 6x squared. But when you add, you must get what? Positive 7x, this one. So the numbers definitely will be 6x and what? X. If you multiply these, you get 6x squared. If you add 6 plus 1, that's a 7. So these are the two that you're going to put into the middle term. Like I said, you substitute into the middle term. So it's 3x squared plus 6x plus what? Plus x. This is same as just 1x. All right, plus 2. 4 terms, 1, 2, 3, 4. So that is by grouping, you group them into 2, factor out what is common from these first two terms. As you can see, 3x there is common, 3x squared divided by 3x, that's x, 6x and 3x, that will be 2. So guys, as you can see already, we have got x plus 2 there. So what are we going to factor out so that it remains as x plus 2? We are going to factor out a positive 1 so that it will remain as x plus 2. If you factor out a negative 1, guys, it's going to be negative x, negative 2, which is different from here. We must have the same bracket, same signs. With that, we can factor out that common bracket of x plus 2. Factoring out this bracket of x plus 2 means we are going to remain with what? With 3x on the first part, and this part you're going to remain with what? Plus 1. So this is what you're going to have. From this quadratic expression, we're going to have what? These two brackets. So this is our case, guys. So here, from this quadratic, we saw that we're going to have these two brackets. So we're going to substitute. That's x plus 2 and what? 3x plus 1, like this. All right, so this is how we're supposed to have our final answers as. So you see, guys, knowing the basics of factorization, we're not going to even waste time on this question if we are knowing the basics of your factorization. So they can give you guys such. You are used to questions where you just substitute like that part where you use your k. Then when you substitute, it will be just, it will be done at that stage. You don't even factorize further. Maybe you can just simplify inside the brackets 2x plus 3 plus a 5. Then in another bracket, maybe we've got something like this. Then another bracket, it has got 2x plus 3, maybe a minus 7. We are used to these brackets where we just combine this and we do not even have much to do in these brackets. But in this case, guys, we're supposed to factorize further the quadratic. It can be even for the linear where there's something that is common. You have the two brackets, but there's something common, 2x plus 4, and another bracket, we have got maybe x minus 3. This cannot be your final answer because there's something common in this bracket. Factor it out. Whatever that you factor out is a multiplication. So meaning to say, if I factor out a 2 here, I'm going to have x plus 2 into x minus 3 as a product, as it is. So this is how factorization, guys, is supposed to be like. So, guys, as you can see, they are testing you. They're trying to adjust the questions so that they become a little bit confusing because we are now used to the basic questions. So as you can see, this one, guys, it was actually an adjusted question. 1.2, factorize the following polynomial expression completely with the aid of the factor theorem. We are to factorize completely. It is us who is to start from scratch. We are not given any factor to consider there. We were not given any factor to consider. All right. So I want you to consider your f of x because I'm going to have this one aside. All right. So we were given, that's 1.2. We are given that f of x is equal to x cubed minus 2x squared minus 5x plus 6 like this. This is your f of x. So remember I said when you are working with the factor theorem, in your factorization, the first thing is to obtain a factor from the number that when we substitute it here, we must obtain a 0. When we substitute a certain number. So how do we find the numbers? Just work with what? 6. What are the factors of 6? Factors of 6. We've got plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. These are the factors of 6. So if you actually have time to work out this type of equation, you try your values, guys, each and every part. So using, in this case, I'm going to use the other part of long division. But what I'm trying to say is that for you to have a long division, you need a factor. So you need these numbers to figure out the factor. So you substitute, let's start with positive 1, f of 1. We substitute that in place of what? In place of x, 1 to the exponent of 3, minus 2 into 1 to the exponent of 2, minus 5 into 1 plus what? Plus 6. You substitute every part of x with a 1. So this was going to give us a 0. You are substituting that. In place of what? In place of x. You're going to obtain a 0. So what does it mean, guys? If you substitute a certain number and you obtain a 0, remember I said that if f of a is equal to 0 like this, if f of a is equal to 0, therefore x minus a is a factor. The moment we bring x, we take this, we introduce a negative, so it will be x minus a. What you substituted to give you a 0, to be written as a factor, it will be x minus that number that you substituted. So in our case, it simply means, therefore, x minus what we substituted, x minus a. What is it that we substituted to obtain a 0? We substituted 1. So therefore, x minus 1 is a factor. This one is a factor of what? The function that we have of f of x is a factor of f of x. It is a factor of this f of x. That is the case. So if you understand this, guys, there's no even need for you to go to the long division. Why? You simply need to try your numbers. You go to 2, you 3, and so on and so on. You just try the numbers that will give you a 0. So if you're going to try this, minus 1 was going to fail, 2 was going to fail, but minus 2 was going to give us a 0. If you substitute minus 2 in place of x, you are going to get a 0. So if minus 2 is giving you a 0, therefore it means what? X minus, our a is what? Our a is minus 2. So it's x minus minus, which is simply what? X plus 2. which is simply what? X plus 2. So this is the case. It simply means also x plus 2 is a factor of f of x. If you understand this, guys, you can even do anyone. So you move on to 3. 3 was going to give us also as this one. F of 3, you substitute in place of x, you put a 3 on your calculator. You are going to get a 0. So what does it mean? Therefore, x minus what? The number that you substitute to get a 0. X minus what? X minus 3 is a factor of what? F of x. Guys, if you are given a cubic function, how many factors do we expect to have? 3. 3 brackets. We expect to have 3 brackets, and this is exactly what we have here. We've got 3 brackets. 1, 2, 3. So therefore, f of x is equal to what? We list our brackets. The first one, x minus 1. The factors are the ones that you write here. The other factor, we said it's x plus 2. The other factor, it's x minus 3. Just like that. So you can have your factor, your expression being factorized that way by just taking the factors. All right. No problem. So that is our first part. Or we can simply use the long division. So if you are using the long division, guys, the first part here is going to be the same. All right. Let me just remove this part. So if you are using long division, everything that I explained in terms of determining the first factor is the same. It is not going to change, right? So that is another way that we can use applying the long division. So using the long division, there are so many, guys. You can even use another one, which is called synthetic division. There are so many for you to factorize this. So using long division, you're going to do the same thing just like what we did to find the first factor, this one. But you're not going to use it now to find the other one. You just find one like this. After finding or after knowing just a factor, any one, meaning to say of the 3 factors that we had as our final answer, maybe one of them is your factor. Maybe you substituted 3 to obtain a 0. You work with x minus 3 as your factor. You're going to use that one. But in my case, I've got what? X minus 1, because that is the first number that gave me a 0. So x minus 1, if it is a factor like this, we are going to divide it into the expression, all right? So let us just use our space here. So we're going to take our f of x like this, okay? So it will be our factor x minus 1 into what? F of x, which is what? X cubed minus 2x squared minus 5x plus what? Plus 6. That's for the long division using the one that you said it's your factor. So sometimes in most cases, they will give you that factor. Say, given that f of x, all right, given that x minus 1 is a factor of f of x, factorize f of x fully or find the other 2 factors. But in our case, we were not given. It is us weird to determine that first factor. After determining it, we apply our long division. All right, so let's apply, guys, our long division. Remember, you divide, multiply, like that. So let's divide x cubed divided to x. X cubed over x like this, guys, was going to give us what? X squared. So that's x squared. It multiplies back. You divide and you're going to multiply back everything as it is here. So it's going to be what? X squared times x, that's x cubed. X squared times minus 1, that's minus x squared. Then subtract, all right? So you bring it down. This part you bring down, then you do subtract. All right. Sorry, I did what? I said divide, multiply, subtract. Where am I going? The bring down. The bring down, you're going to take it here at the end there. All right, so let's subtract and see what you're going to have. X cubed minus x cubed, that's a 0 there. And these two, what are we going to have, guys? Minus 2 minus 1. So it's like this, minus 2 minus 1. Take note, minus, minus. So that was going to be a plus there, which is what? Negative 2 plus 1 is what? Negative 1. So that's negative x squared. Then we bring down these that are remaining, the minus 5x and what? The positive 6. Repeat these stages, guys, as we had them. Divide again. So it's going to be minus x squared divided to x. So what are we going to have? That will be minus x squared and x. There are two of them. So if we divide, we're going to remain with what? With the 1. So that's minus x. Whatever that we have here after dividing, here we multiply it back everything. So meaning say it's minus x times x. Minus x times x. That will be negative x squared. Minus to a plus, that's negative. All right. Minus x to minus 1. That's minus x times minus 1. That's positive x. We subtract. So let's subtract. Okay. Minus x squared minus x squared, guys. We are subtracting the same thing. So definitely that will give us what? A 0 there. Minus 5x minus, what are we subtracting? Positive x. So it's like this, minus 5 minus 1. This is 1. Minus 5 minus 1. So that was going to be minus 6x. We drop the part that is remaining, positive 6 as it is. That's a positive 6. So this is it, guys. Let's divide again. Minus 6 to what? Sorry, so we're going to divide again. Minus 6 to x. So minus 6x over x. So this was going to cancel. We get what? Negative 6. We multiply this negative 6 to everything that we see there. So that's negative 6 times x, negative 6x, negative 6 times 1. That was going to be positive 6. Just like that. Then subtract. So as we can see, guys, we are simply removing the same thing here. It is the same thing that you are removing. 2 minus 2 is a 0. 3 minus 3 is a 0. So if we have minus 3 and we subtract minus 3 from it, guys, you get a 0. You are removing the same thing. So that is, if you are removing minus 6 from this minus 6, it's going to be 0. Minus 6 minus minus 6. That is the case. So let's do our revisions in as much as we can. So if you are using the long division like this, guys, like I said, there are so many ways, different ways of applying your factorization. If you are using this factorization, whereby you apply the long division like this, you take your f of x now and present it this way to say our f of x is equal to, remember, we're dividing by what? X minus 1. And what is it that we got when we're dividing? This is what we got here. X squared minus x minus 6. This is what we got. So we are going to multiply it here. X squared minus x minus 6. This is same f of x as it was here, but now it is being factorized partially. But it is supposed to be what? Fully factorized. So we have to check, is this quadratic expression, in our quadratic expression that we have this one, can we factorize this? That is the question. So we are supposed to figure out of this quadratic expression. So lucky enough, in our case, the coefficient of x squared here is what? Is 1. So it's just going to be a direct factorization there. Put x here, put x here. X times x is what? X squared. What are the products? The factors of negative 6. But these products must add up to what? Negative 1 here. The factors, negative 6, two numbers. You multiply two numbers, you get negative 6. But when you add the two numbers, you must get negative 1. So 3 and 2, there is something here on 3 and 2. So it can be a minus 3 and 2 or a 3 and minus 2. Adding this, minus 3 plus 2 is what? That's minus 1. 3 plus minus 2, that's positive 1. So which gives us a negative is what? The minus 3 and the 2. So this is what you're going to have, minus 3 here and a positive 2. So as we can see, these are exactly the same answers that we obtained for our f of x using the previous way of just determining the factors, trying out the factors until you obtain all the three factors. So it is not always that the trial and error where you try all the factors it's effective. Sometimes you get to a point where you will be limited to try as much because you might be having factors of 2x plus 3 like this. So in that case, you must be careful. So choose the method not just because it is easier in the view, but it must be something that when you are stuck, you follow. This one, guys, is a follow path that you're supposed to follow even to check your answers, because always, if it is a factor here, you must get a 0 always. If we are dividing here, the one that we used here, the x minus 1, if it was not a factor, you were not going to have 0, 0. You were not going to have a 0 here. Only as a factor, only this is to confirm that truly this is a factor. So under exam, as long you have done your subtractions properly and you obtain a 0 there, it means truly that was a factor. And also this other part becomes a factor. So the product of these two gives us what? F of x. But this one has to be factorized again completely. Remember, that is what we need. Just like that. So guys, I don't know which one is the easier. There are so many methods. Revise also from grade 12 factorization there, the synthetic division. There are so many methods, guys. If you check even his videos now, there are so many methods. 1.3, solve for x. By completing the square, you are given an instruction there to follow. Not just to solve, but by using what? Completing the square. So how can we complete the square here, guys? We are given 1.3, also completing of the square. The way that you do there can differ, but let me just explain. I don't know which way that you're going to get. So if we check already, there's a constant on the other side. So let's just leave it like that. Some can take this to the other side, but there's no need, guys. Leave it there. So you check if you are using completing of the square method, always the coefficient of x squared must be 1, remember. We must have a 1 here, not a 2. So what can we do to get a 1? We have to divide by that number 2. By 2 here, by 2 here, by 2. Always the coefficient of x squared must be what? Must be 1 before you use this method. That is what you're supposed to make sure. Before you even think to say, now I'm going to do this, make sure the coefficient here of x squared is what? Is 1. I'm saying only for completing of the square method, not, okay, any other way, guys. So this is minus 3x over 2. Remember, it is the same as writing as minus 3 over 2x like this, which is equal to 5 over 2. So take note. If I write negative 4x over 3, it is the same thing as minus 4 over 3x. It is the same thing here. All right. So do not panic here. I'm just trying to let you see this number here, the coefficient of x, the number that is what affecting x. It is important that we properly see that number in our completing of the square method. All right, so when we have the coefficient of x squared as 1, as we have now here, what are we going to do? Okay, this is what you're going to do. You find half the coefficient of x squared. So we are going to find half the coefficient of x squared. Coefficient of x squared, like not here, but the half of the coefficient of x, you must square it. So you square half the coefficient of x. Square half the coefficient of x. So what is the coefficient of x in our question? In our question, this is where we have x here. The coefficient of x is the number that is what? Multiplying x. So half of that. And we square it. So meaning to say we need the half of what? Minus 3 over 2. Minus 3 over 2 like this. Squared. Square. The square half of the coefficient of x. This is the one that we need. So that's it. We can even use our calculator. We can just multiply 1 times minus 3. That's minus 3 over 2 times 2. That's 4 squared. All right. You can even simplify this, guys, and you get 9 over 16. It's up to you. Or leave it like that. So this is square, this one, guys, is the one that we need. This one is the most important. So what are we going to do? If it is an equation like this, okay, remember this was your first stage to find this. So what are you going to do? You add. Okay, you add, let me just say item 1. So you add 1, both sides. Both sides. It's an equation, remember. Whatever that you do on the left-hand side must be done on the right-hand side. When I'm saying this one, guys, I'm simply saying what I explained on the first part. So you add half the coefficient of x squared. You add the square of half the coefficient of x that we had here. This one, you're going to add both sides of your equation. So that will be x squared minus 3 over 2x. Then we add it. So it's plus minus 3 over 4. So this is minus 3 over 4 squared. So this is what I mean. But we must add this both sides. So on this side of our equation, we are going to do the same thing. 5 over 2 plus, we add that square, minus 3 over 4 squared like this. Okay, so this is what you're going. This is, here, guys, this is the part of your completing of the square. These two stages, you're supposed to follow them as they are. Half the coefficient of x squared, you edit both sides. So now at this stage, on this left side of your equation, you factorize on this side. You are going to factorize. But how do we factorize, guys? We are simply going to take what we see on the first here. Remember the factorization of perfect squares. I mean the simplification or the expansion of the perfect squares. You simply take what you see, the ones that are being raised to the exponent of 2. It's what here? It's x. What about here? What is raised to the exponent of 2? It's minus 3 over 4. That is the most important part of leaving it like this so that you properly see the sign which was there. So it's what? Minus 3 over 4 as it is. Minus 3 over 4 as it is to the exponent of 2. So that's it. You have factorized. You have factorized this. These are perfect square type of quadratic expressions, guys, that you need to work on as a topic that you can actually work on it to understand more. So not waste your time there, guys. This is how you factor. You take this one and you take this one. The ones that are being raised to the exponent of 2. You combine them as they are. If it was a positive here, you're going to take it as a positive. The meaning you say, yeah, it was supposed to be also a positive. So that's it. All right. Anyways, guys, that's it. Let's simplify the other part. There we're just going to use our calculator to simplify or to evaluate that. So this is it. We've got 5 over 2. That's 5 over 2 plus open bracket minus 3 over 4 minus 3 over 4 like this to the exponent of 2. So that's it. We are going to obtain what? 49 over 16. So this was going to give us 49 over 16. So that is it. Okay, now we can solve directly as we are used to this stage, introducing the square root to get rid of the square. That was going to be the square root, so from there, it's just solving, guys. All right. So that will be x minus 3 over 4 is equal to the square root of this. All right. That is, we know that the square root of any number is what? Plus or minus. So these numbers, guys, are direct. We can find their square root. Use a calculator there. The square root of the answer. That is what? 7/4. So as we can see in our case, we are going to obtain exact values. So like numbers that can be simplified. The square root of 49 is a perfect square. 16 is also a perfect square. So that's why we see it is direct like this. It's not always. Sometimes you can have those decimals. That's when you round off to the 3 decimal place, this and that. All right. But in our case, guys, it was just direct, as we can see. Take the -3/4 to the other side. So that will be positive. So x is equal to 3/4. But there's plus or minus there. So it's plus or minus 7/4. So in this case, there is no even need for us to combine to say, okay, we are adding this over 4. Just use your calculator, guys. Separate. There's a plus there. There's what? There's a minus. So you're going to separate this. There's a plus. So starting with the plus, what are you going to have? 3 over what? 3/4. We add this to what? We add it to 7/4. Just like that. We add this to 7 over what? 7/4. So that was going to give us 5/2. So that's 5/2, or x is equal to, you do the same thing with a negative this time. So you're going to put a negative here. All right. So let's subtract here. That was going to give us what? -1. So x is equal to -1. These are the possible values of x that we can have. So guys, we must be very careful. The method that you are being given, it is not just you see the square there, you simply use x is equal to minus b plus or minus. No. When they specify by this, you must use that method that you are given them. All right. So anyways, that is what we had, guys. Let us check another part of our question. Question 2, which is first part 2.1. Simplify this. All right. So let's just try to write it here, guys, so that we do not end up having mistakes trying to rewrite this aside. That's 2.1 here. X to the exponent of 1/2 minus 64, x to the exponent of -half. What can we do here? What can we do? We can see the x to the exponent of half is something common, but not that common, because this is positive and this one is negative. So we cannot factor this one out. So what can we do? Let's try to simplify. Remember our exponents. X to the exponent of -a is 1 over x to the exponent of 8. Carries what? 1/2. Remove a negative. Let's try to have it that way. X to the exponent of a half minus 64. Definitely you divide here, because it will be like this: 64 times 64 times x to the exponent of -half. So for you to get rid of that one, it will be 64 times 1 over x to the exponent of a half. So take note, 64 is same as what? 64 over 1. So we must be careful. So it will be 64 times 60 times 1, which is 64. 1 times x to the exponent of half, which is what? X to the exponent of a half. So on this part, most of you guys, you end up making mistakes where you write the 64 also here to say 1 over 64x. No, this one will be wrong. 64 is not affected by the negative exponent. The negative exponent is on x, not 64. Okay. Let's do the same thing in the denominator and see. This is positive. Here, let's leave it like that. X to the exponent of a half minus 16. There is another part here, 64, this one, just like here. So it was going to be plus 64 over x to the exponent of a half, like this. So this is where we are now. we have used this part of getting rid of what? The negative. But if we consider, guys, this is the numerator on its own. It's complicated. We've got a fraction. The denominator, it's complicated. We've got a fraction. Let's get rid of these fractions. All right. This is same as over 1 over 1. This is same as over 1. So in the denominator, what is our LCD or the LCM? X to the exponent of a half. So you're going to multiply each and every term by x to the exponent of a half to remove these fractions. X to the exponent of a half. X to the exponent of a half. We are doing this in the denominator and also in the numerator. Here we're going to multiply x to the exponent of a half. Here we're going to multiply x to the exponent of a half, each and every part. So if we multiply x to the exponent of half and x to the exponent of a half, we know that was supposed to be what? X to the exponent of a half squared. This number times this number, x times x, it's what? X squared. So if you multiply this and this, you're going to be squared. So let's leave it like that because mostly these are quadratic, guys, that you form there. So just leave that with a squared as it is. So that was going to be what? X to the exponent of a half squared. We know that x to the exponent of a half squared, guys, is x, but leave it like that. Okay, this one and this one cancels, as we can see. This one, it cancels its numerator to the denominator. This one is this, like this. So you're going to get what? Negative 64 that is remaining. Everything over what? We are back again, the x to the exponent of a half times x to the exponent of a half. So it simply means we've got x to the exponent of a half squared, right? Minus 16 times x to the exponent of a half. It will be minus 16 x to the exponent of a half as it is. This one and this one was going to cancel. So you're going to have plus what? Plus 64. Just like that. So this is where you are, guys. Analyzing what we have here. Analyzing properly what we have. We are simply having those quadratic expressions, but they are being hidden from this exponent part. But now we are back to those quadratic expressions because this is simply a factorization here to be done. What else can we simplify there? Factorize. Difference of two squares. So we have a difference of two squares here. Remember, a difference of two squares. A term, in this case, raised to the exponent of what? Of 2. What about 64? Can we write 64 in the same manner? 64 is the same as 8 to the exponent of 2. 8 to the exponent of 2. Just like what we have here. To the exponent of 2. Remember your difference of two squares. A squared minus b squared is equal to what? A minus b into a plus b. So this is our a, and this is our b, which is 8. So if our a is x to the exponent of a half, this one, which is inside the bracket. So it was going to be x to the exponent of half minus, remember, a minus b. So that's minus b, which is this 8. 8 to the exponent of 2, the one that is raised to the exponent of 2. So that's 8. Another bracket is simply going to what? To add x to the exponent of a half plus what? Plus 8. Just like that. So this is it. Everything over what? The denominator. Can it be factorized? So if you were to check properly in the denominator, guys, it is either, because here it was clear a difference of two squares. Yes, you could have even also introduced the k part where you can say, let k be equal to x to the exponent of half. The same thing even for the denominator here. If you properly see your quadratic expressions, you can see that we have that format of a minus b squared, this one, a minus b squared like this, which is equal to a squared minus 2ab plus what? B squared. But this is the same formula that we see if we check properly. So there is just a single bracket of a minus b. What is our a? This one. What is our b? The last part that we check here is 8. What? It's 8 squared. So our b is what? 8. So if we understand this, guys, it simply means we've got two brackets of x minus half, this one, a minus b squared. So it's x minus half, which is our a, minus what is our b on 8 squared. So it's 8, like that, 8 squared. So the b is the 8 from 64, 8 squared. But they're saying a minus b squared. So that's a minus b squared. We have factorized this by knowing the quadratic expression, this. But if you do not know that, guys, this, we are simply going to have the same answers by using this way. We can simply let, because we want to factorize this, remember, we want to factorize this quadratic here, this one, that is remaining now. Like I said, the first one, it was a difference of 2 squares, so it was easier. But for this one, guys, what can we do? X to the exponent of a half to the exponent of a 2 minus 16x to the exponent of a half plus 64. We can simply let k to be equal to x to the exponent of a half, which is the same here, just like our previous question where we introduced a k here. That is the same thing. So if we introduce a k in that part of x to the exponent of a half, what does it mean? It means we are going to have this as k squared. Remember, this is k, but it is being what? Squared. So that's k squared minus 16. This is what? This is our k. So that's minus 16 k plus what? Plus 64. Just like that. Your factorization, you are used to this, guys. So you're simply going to have what? Two brackets. The coefficient of k squared is 1. So you know that you're going to have a k here and another k here. Then you consider, just like the previous case, guys, what are the products of what? 64. But these products must add up to what? Negative 16. So you're going to see that was going to be negative 8 and negative 8. Negative 8 times negative 8. That's a positive 64. Negative 8 plus negative 8. That's a negative 16. So you've got negative 8, negative 8. Two brackets which are the same. So it simply means we have got what? K minus 8 squared. These two brackets are the same. But remember, we introduced the k here to say let be this. So we are going to bring back where k is, our x to the exponent of half. So it was going to be what? In place of k, we bring back x to the exponent of a half minus what? Minus 8 to the exponent of what? To the exponent of a 2. Exactly those two brackets that I wrote here that I erased, you're going to have the same. So factorization, guys, is in your hands. You see, this is factorization. So I said N3, guys, is all about factorization. Factorization, the most part of your algebra, question 1, question 2, factorization. So these are the two brackets that you're going to have. X to the exponent of a half minus 8 raised to the exponent of what? Of 2. Meaning to say there are two of them. So you can even write as two brackets if this one is going to give you a confusion, write them as two brackets. X to the exponent of a half minus 8 that you can properly see. Another one, x to the exponent of a half minus 8. That is what it means. So guys, as we can see, the numerator and the denominator, there's something common. So these two can what? Can cancel. These two are exactly the same. So we are going to remain with what? From the numerator, we are going to remain with x to the exponent of a half plus 8 over what? X to the exponent of a half minus 8. As we can see, guys, we are done. There's nothing common. There's no factors. There are no factors that we can say we can factor out. There's no other simplification, guys, that we can do here. Yeah, in simplest form. Remember, every simplification, factorization that you do is supposed to be as far as possible in simplest form. That is as far as possible, completely. Solve for x, logarithms, a logarithm there on question 2.2. All right, this one, let's figure out, seems to be an interesting question that we can use a lot of things here. All right, let me take this question aside because here, guys, we're going to have a lot of things here. So that's 2.2. Here we're going to have a lot of things. Okay, no problem. So on 2.2, we are given to solve for x, given the logarithm of 3 minus x in the base of half. So it is in the base of half, and this is equal to the logarithm of 1 over x squared like this, in the base of 2 plus a 2 like this. Okay. I want you to see that here, there are so many things that are considered. We can either change this 1 over 2 here, because our logarithms, they do allow us to change this to a negative. From the laws, we can say, let's say we are given log a in the base of x. Okay, let's use b to the exponent of negative n. The negative can be used here, this one that we see. So we can have as negative log a in base of b. Is it going to be the same when we use that way? In this case, it affects b, not a. This one. It affects b, not a. So meaning to say, working with a negative here, it's going to be complicated because it is on the base, not on the exponent of this one. All right? So let's leave that one for now in terms of changing that to be a negative. What we can do, if you want, is to change to have it as the same base, like to have like log 3 minus x like this. Remember, it is the base there, which is what? Which is half. So it simply means we were having a division by a logarithm of a half. That is what it simply means. In the same base, we are in the base of 10, remember. We can even take this one, negative 2. That is where you can write 2 to the exponent of what? Negative, if you understand that way. So it will be what? The logarithm of 3 minus x like this. Do not write this, guys. I just want you to see. 2 to the exponent of negative 1 like this. Our logarithm, the logarithm, they allow us to drop this negative. Now, so it will be the logarithm of what? 3 minus x over what? We drop this negative. So it will be negative logarithm of 2. So if you want now to use the same law that we used here to combine this as a single log, writing it back, knowing that you're in the base of 10, you can rewrite back. So it will be minus the logarithm of what? 3 minus x in the base of 2. The same way that I was explaining there. So this is all about the laws, guys. You see the negative there. Be taken to the other side. So if you understand your laws this way, you can simply apply that law. So this one is it's interesting. It's an interesting question. Let me explain also this side. Then we figure out which one is easier. On this side, we can also do the same changing of the bases, because as we can see, here we've got a half and here we've got what? A 2. So we can try to figure out how can we have the same base to have this half that we see. Remember, it's a half. So it's complicated to work with that half actually. But how can we have it? How can we obtain that? All right, so the only way to have that is using that law again, which is the one that I was using there, that if you're given a logarithm of A over a logarithm of a B, provided the base is the same. All right, I want you to see it from your formula sheet they gave you like this. It will give you log A in the base of B. All right, I think I have the formula sheet here. Guys, can you go through with me here? The logarithm of A, I want this one. Logarithm of A in base of B, this one. It is equal to what? Log A in base C over what? Log B in base C, which simply means as long the base is the same, as long it is the same base here, as long it is the same base that you have, you can write logarithm of this number in the base of that one. Meaning to say, if I'm given log 2 over the logarithm of 3, this is log 2 over the logarithm of 3, provided I'm in the same base. So the base, I can use n, I can use 5, I can use 6, I can use any. So in the base of 10, let's say we are using the base of 10, it simply means this is going to give us the logarithm of A. What is on top? It's what? It's 2. In the base of what is in the denominator. So it will be a single logarithm like that. So as now, we want to bring the half here into our question. So we are going to do a vice versa, guys, to say if we have got a single log, it can be written back like this in any base. If you have got a single log like this, it can be written back like this in any base. If C represents any base, as long it is the same base, but it must be any base being the same, it means we can bring also the base of half this one into our question because it is the complicated one. So we can bring it because it is also a base. So how do we bring it? All right, so I'm going to work it from the right-hand side. From the right-hand side. This is, now we can write, we can start to write, guys, whatever that we wanted to write. So this is log of 3 minus x. You could also work it from the right-hand, from the left-hand side. It's still fine. But as for me, I want to work with the complicated part there. So this is it. On this logarithm that we have here, we are going to change it so that, not to change it actually, but to bring the base of a half this one, because we want it in our question. So how can we bring the base of a half? This is the only law that we can use, which tells us that any base can be introduced as long you divide. So it will be like this. It was supposed to be like this. The logarithm, remember, this is the number here as it is. It's a number here, 1 over x squared. It represents your A, just like, where are we? Here, just like here, our A. This one, the 2 here, represents the B, just like here, the B. So if you consider this properly, guys, we saw that it was going to be what? Logarithm of A in base of C. So it is supposed to be logarithm of this. This is our A. Logarithm of 1 over x squared. 1 over what? X squared, like this. In a certain base, we are supposed to have a certain base here. In a certain base. Over what? The logarithm of what? B. B was the base. Now it's a log. So it will be the logarithm of our B. Our base in this case is what? It's 2. In a certain base, but this base is supposed to be any and being the same. So that is where we are introducing the base, this one, because we need a base of what? Of a half. These guys, I could have used the base 10 here. I could have used the 2 here. It will give me the same thing. I could have used any one. Is it base of 3? Is it base of 4? Is it base of 5? So in choosing those bases now, we are not going to just choose any, because we have a restriction here according to our question that we are limited to. Remember, we are limited to what? To this base of half, the one that we wanted. So it was going to be in the base of half, in the base of half. Change of base, these logarithms for change of base, these ones, they are complicated, I understand, but please try to do as many questions. Change of base, they are logarithms on what? Change of base. So we have changed the base. Our original question here, what was the base? The base was 2. But on this part, guys, everything has changed. We are now in the base of what? In the base of half, in the base of half. So this is it. All right. So this 2 is not affected for now. Just going to write it as what? As plus 2. We wanted to change this part to be in the base of half, not changing the question. Guys, please take note. We haven't changed anything here. No. Look at this law properly. Log A in a certain base over log B in a certain base is equal to what? Log A base B. So meaning to say, if we are having the same base as this one, we can have it back like this. Log of this in the base of 2. Log of this in the base of 2. So we haven't changed the question. We haven't. As you simplify bringing something new into the question, don't change the meaning of the question. Most of you guys, you'll be changing the meaning. Here we are still with the same meaning of our question. All right. Anyways, guys, this exam I'm now doing as if I'm introducing a topic. If you do not understand, just go through the basics, guys. Let us quickly go through. So this one can be simplified further. There, guys, we can even just use our calculator. Yes, we are not allowed, but we can just use our calculator. But how do we simplify this? I have explained this law, guys. I was saying, if you are given the logarithm of a in the b to the exponent of -1 like this, if you're given this as a negative, it is the same as negative. You take that negative exponent. So let me not use a negative because you think that it will always be a negative. All right. So let me say a b to the exponent of n. When b is carrying is carrying an exponent, b is having a certain exponent. Is it 1? Is it 2? Whatever that you have. You can take that exponent to multiply the whole log. So it will be n, the logarithm. So this one, it will divide, guys. So it will be like this one. It will be the logarithm of a in the base of b like this. But in our case, we have to divide by that n. All right. When it is an exponent here, when it is log a to the exponent of n in the base of b, in this case, you drop the exponent to multiply the logarithm. Remember, you're used to this one. So it will be n logarithm of a in the base of b. It multiplies. But when it is here, it's going to divide. So when we have that as a negative, we simply put the negative here because a division by a negative, guys, you don't see it. But actually, it was supposed to be what? A division. It's only that you do not see this part of what? Of a negative to say, all right, I'm dealing with a negative. So we can simplify this in that way. So it was going to give us what? A negative. Let's say you don't understand this, guys. How best can I explain? Just use your calculator. On this one, guys, just use your calculator. If you do not understand this, there's no harm in it. There is no effect there. All right. Or you can bring back those laws again to say it is the same as logarithm of 2 over what? The logarithm of a half. But we must choose the best that we can understand better. We cannot use base 10. We have to use the base of 2. Since we have a 2, we can use the base of 2. So log 2 in the base of 2 is what? We know that it's 1 over what? The logarithm of a half in the base of 2. It is same as logarithm of 2 to the exponent of -1 in the base of 2. Remember, I said an exponent, you drop it. So it was going to be -1 in the logarithm of 2 base of 2. Where log 2 base 2 is what? It's 1. So it will be minus times 1. Log 2 base 2, this one, it's 1. But we are saying -1 times 1 is going to be what? -1. So as you can see, we're going to get -1. So this is what I'm trying to explain, guys. This was going to give you -1. So if you do not understand there, guys, you can use your calculator. Don't limit yourself on this one. Just take your calculator. Where's the log here? The logarithm. We are in the base of what? We are in the base of half. The logarithm of what? Of 2. You're having this as what? Logarithm of 2. That's it, minus 1. Just like that. All right. So, guys, it's just like that there. But for those who want to be into mathematical presentations, that is what you're going to have. That is what I was trying to explain there. So here, it is going to remain as it is, the logarithm of 1 over x squared in the base of what? In the base of half. Remember, we are now using the base of half, but everything is over what? Remember, we simplified this only, this, the denominator only. This is the one that gave us what? -1. All right, so we've got a +2 here as it is. All right, this is where we are. What can we do and where exactly are we even going? Where are we even going? Having the same base here can allow us to perform simplifications of this nature, where we have got the same base, addition of logarithms, adding log A and log B together. It is because you'll be having there the same base. So it allows that if you're adding logarithms of the same base, we can multiply the numbers under that same base. For a subtraction of the same base, we're going to divide the numbers under the same base. So having that in mind, guys, can help us in our question. Having this in mind, because we've got a half here. And here we've got also a half. So we must bring these to one side of the equation. But how can we do that? Let's have this, guys. Remember, 2 over -1 is -2. So the logarithm of this, guys, when divided by -1, it simply means we've got what? The logarithm of 1 over x squared. It simply means we've got the logarithm minus here, minus, you multiply it there. It's just a division, guys, in the base of half. From this -1, it is on that log. It's just like x over -1. It's what? Minus x. Even if you're dealing with the trigonometry, sine of x over -1, it simply means minus what? Minus sine x. Nothing to worry about there. All right. So the +2 is not affected. It was on a log, this one. It's not on 2. It's not on this one. No, it is just here. So it affects only where it is. The rest of your question is not affected. So meaning to say, we are going to have it as it is. This is where we are. So looking into that law that I was talking about, that it can be a subtraction of logarithms as long as we've got the same base, or it can be an addition. It brings us to the conclusion that one of these logarithms has to be taken to the other side, since we are using the same base, base of half, a base of half. So let's bring this to the other side so that we can simplify those two together. So the negative definitely is going to be a positive. Remember, this is negative, crosses the equal sign. It was going to be a positive. So that's log 3 minus x in the base of half. A negative to this side gave us what? A positive. So that's plus the logarithm of 1 over x squared, like this, in the base of what? In the base of half. All right, so the whole of this is equal to 2. We are just left with what? We are just left with 2 on the right-hand side. From our law, addition, same base, allows us to multiply the numbers that are being affected by the logarithm. So in our case, we have got these terms, this term and this term. We're going to combine them together. So it will be like this, 3. Let's just start with this one, which is a single term. So it will be 1 over x squared into 3 minus x, just like this. So we multiply these two here. We multiply under the same log in the base of what? In the base of half, under the same base, same log, same base. So this is equal to 2. This is where we are. What is it that we can see or that we can say about this? A single logarithm like this. This is now a single logarithm. Remember, this is now a single part that you are considering here. When I'm saying it's a single logarithm here, you are now considering this as a single term. That's why I opened a bracket. So it is a single log because we've got what? A term and its base equal to a certain number. So how do we evaluate such single logarithms? All right. There is no, okay, the law. Here they did not mention about the law. No problem. Let me list it here so that we can understand each other. So it follows that a single logarithm of this nature can be rewritten into an exponent, or where it is written in exponential form. The logarithm of a in the base of b when it is equal to c. Remember that it can be changed, where a is equal to b to the exponent of c. B to the exponent a here, this a is equal to b to the exponent of c. So in this case, this is our a, this is our b, and this is our c. So we are saying a, this part here, this is your a, as it is 1 over x squared into 3 minus x, as it is equal to what? B, the base to the exponent of c, which is our answer there. So our b is what? That's a half to the exponent of what? Of 2. It is a law of conversion from one logarithm to exponent, exponent to logarithm. So you see, they are playing around with you this time. Guys, they are trying by all means to bring every concept that you know, every concept. And after that, not only just a simple equation that you have. Look at the equation that we are having. Complicated one again. They are trying by all means. So do revise, guys. So what does it mean on this part? If you're given, I explain this, guys. 1 over 4 times x is same as x over 4. So if you're given 1 over this times this, it simply means we have got 3 minus x over x squared. This is just like over 1. So it's 1 times this one times this one. Numerator to the numerator, remember? So this is equal to 1 over 4. From this 1 over 2 squared, it's going to be what? 1 over 4. 1 squared is 1. 2 squared is 4. You can even use your calculator. So let's cross multiply, guys. As we can see, I've got a single fraction, a single fraction. So cross multiplication can be used. X squared and 1, that's x squared is equal to 4 into this. So 4 is going to multiply everything. 4 into 3 minus x. So that's 4 times 3, which is 12. 4 times minus 3, which is minus 4x. So taking this to the other side, as you can see, we now have a quadratic equation. Highest exponent is 2. So one side must be what? Must be 0. So x squared plus 4x, the 12 to the other side, minus 12, that's equal to 0. So we can solve our quadratic equation at this stage. It's now a quadratic where from our quadratic equation, since the coefficient of x squared here is 1, I can simply have what? X here, x here. What are the factors? The products of what? Negative 12. But these products, they add up to 4. Negative 12. Two numbers, you multiply two numbers, you get negative 12. That's 6 and what? 6 and negative 2. If you multiply this, you add, you get a positive 4. Minus 6 and 2 was going to fail. If you add these two, you get negative 4. But truly, if we multiply these two, we are going to get a minus 12. But when we add, it's minus, not positive. So this one was going to fail. So where we get a positive 4, it's on 6 and what? 6 and minus 2. So that's plus 6 minus 2 like this. So meaning to say x is equal to what? The minus 6 to the other side. I mean, the 6 to the other side was going to give us what? Negative 6. The minus 2 to the other side was going to give us what? A positive 2. So these are the possible values of x that we're going to have in our case. So guys, you see how complicated it was, like go through all these stages. And also it's a logarithm. So you must test these values of x that you are given to see if they do satisfy the log that we are given there in place of x. Guys, look, okay, this is where we started from. All right. So that is the stage, guys. You simply have to make sure that you go through each and every stage. You could have also worked from the right-hand side, but guys, it was going to be a lot of things here. If I explain that, I'm just going to try in my next classes to do questions of this nature so that we can figure out how to solve, because you can do it from any side, from the left-hand side, from the right-hand side, it will be up to you. But I wanted you to see something here because of our values. You saw one value is negative, one is positive there. Let's bring in our x and test if can x be negative here? Guys, it is not just to say x is not minus 1. Check on your equation where x is. This is our original equation. X is not on the base here. And even if it is on the base, wherever x is, in our case here, wherever x is, if we are to bring back our x here, where x is, there was another one, it was what? Minus 6. Another one was what? Positive 2. Bring a minus 6 here, guys. Minus is what? It will be a positive. Bring a minus 6 here, square it, because it's minus x squared. So these answers both are supposed to be correct. We are not limited. The x is supposed to be minus 6. At the same time, x is supposed to be what? 2. All of these. Because once you bring back that x, the x is not on the base where we've got maybe the logarithm of 2 in the base of x. Or where we have even, it can be like this, where we have got something that has got x here. Let's say it was, let's just say x plus, let's just say x plus 3. All right, in the base of half. When you substitute the x here, the minus 6, you put minus 6 here. Minus 6 plus 3 is what? Minus 6 plus 3 is minus 3. This one, when it is like, it cannot work. It cannot work because at the end, your logarithm is carrying what? A negative. But not on our case, guys. It's 3 minus x. Meaning to say it's 3 minus, you substitute your x. If it is negative, x is what? Negative 6. So it was going to be what? 3 plus 6, which is what? 9. So x can be negative 6 there. Put it there and substitute and prove your left-hand side and right-hand side is going to be the same. And for this 6, if you substitute minus 6, it was going to be minus 3.169, something like that, which is the same also for the what? The right-hand side. So it is not always where you see a negative, then you say the negative is not part of my answer. So I'm saying this because if you check your memo, they are saying x cannot be equal to minus 6. No, x can be equal to minus 6 in that case. It is just maybe a mistake. They did not check properly in terms of the presentation of the final answers there, but that x can be negative. So these two solutions are part of our answer. All right. So let's do revise, guys, as many questions as we can. All typical exam questions that you think they're challenging, go through them. The more you go through those questions, they won't be as challenging as you think. It is because you won't be revising those questions, so they become more challenging. 8 marks. All right, that was a lot. Anyways, let's see, guys. Question number 3. Question 3, make T the subject of the formula. This one I explained, I think, April. No, it's supposed to be August 2024. In fact, from April, they repeat this question, guys. They can just put numbers. Yeah, A is equal. They can put a 5. They can. This one they do repeat. This one they do repeat almost each and every question paper. You find this similar question. So A is equal to dE to the exponent of RT. Make what? T the subject. So how can we make T the subject, which is on the exponent like this? All right. Since we have E already, we have this exponential, this one, the E is already there. We are going to introduce the ln. we are going to introduce the ln, the logarithm, the natural logarithm, the Napierian logarithm of a ln. Why a ln? Because a ln gives us 1. A ln of E is equal to 1. So we're going to introduce ln both sides, but take note, only when it is a single term, when you make this one, the E to be the subject. So the first thing, you must make E to be the subject before you introduce the logarithm, the ln. So how can we make E, not T? I'm not talking about T, I'm talking about E. What is affecting E? It is what? The D. So let's divide by D like this. So it means A over D is equal to what? E to the exponent of RT. The exponent is on its own. Now logarithms can be introduced, the Napierian logarithms of what? A ln. So you're going to introduce a ln, both sides, a ln here, a ln. So this is a single part like this. So once you introduce a ln, guys, what are you going to do? These are logarithms. Remember, when you have an exponent on log, you drop the exponent. So that's the case. So it was going to be the ln A over D is equal to, we drop this exponent, which is what? RT. So that's RT, ln of what? Ln of E. Where the ln of E is what? Is 1. The log of E is 1. This one. When we have this, it is important to note that's equivalent to what? To 1. So simply means that the ln, all right, sorry. So it simply means you're gonna have the ln of A over D is equal to what? RT. Since this is ln and the ln is what? It's 1. The ln E, ln E. What is that we want to make the subject? It is T. And there we've got a product. R is multiplying. So what are you going to do? Simply divide. So we divide by R both sides. So that was going to cancel. So T is equal to the ln of A over D over R like that. All right. So that was it, guys. You can also subtract these two. Remember that the ln of A over D like that, it simply means we are having ln A minus the ln of what? The ln of D. The log of A minus the log of D over R. You can even write it that way. You're done, just like that. So this one, they do repeat this type of equation. They can even put numbers where you see the D there. They can put a number. Where you see the R there, they can put a number. A is equal to DE to the exponent of 5t. A is equal to 4e to the exponent of mt. They can choose any part. Just make sure that you do revise, guys. Make T the subject, or they can even ask you to make R the subject there. Any one of those. 3.2, they are saying when we multiply the square of a number, when we multiply the square of a number, do we know the square of this number? We do not know. So let a number be x. 3.2. So let the number be x. All right. So let the number be what? Be x, the one that we do not know. So they are saying when we multiply the square of a number, the square of a number, it's like this, the square of a number. So when we multiply the square of a number by what? By 3. This is the square of a number, this one. We multiply it by what? By 3. It simply means what? 3x squared. We multiply it by 3. It simply means what? 3x squared. And it's another statement. We are done here. The statement, the first statement here is done. We are done with the first statement. We move on to another one. And what happened? Add. What are we adding? Add it to the number multiplied by what? By 7. Add it to the number multiplied. So we are saying when we square that number, then we add that multiplied. We are not just adding that number. That number is supposed to be being multiplied by what? By 7. So we are going to multiply the number by 7. We are adding. It must give us what? A 20. It gives us 20. So what is it that you have formed? It is an equation, a quadratic in actual sense, a quadratic equation. So we can solve this, guys, using your factorization. Remember, quadratic, one side must be a 0. So it's going to be 3x squared plus 7x. The 20 to the other side was going to be negative 20, which is equal to 0. So using your factorization, your quadratic formula, whatever that you're going to use, you're going to solve this. So, guys, we've been using factorization. Let's just use our quadratic formula. X is equal to minus b plus or minus the square root of b squared minus 4ac everything over 2a. Remember, quadratic formula also given in your formula sheet. From the equation ax squared plus bx plus c, from this format, a is the coefficient of what? Of x. So it means in our case, x is equal to minus b. A is the coefficient of x squared here, x squared. B, the coefficient of x. So it is going to be minus b, which is minus 7, plus or minus the square root of b squared. What is our b? That's 7. So that's 7 squared minus 4 times a, the coefficient of x squared, which is 3. C is the constant, which is what? Which is minus 20. So like this, everything over 2a. So that's 2 times a. Remember, our a is what? Is 3. Just like that. So we can solve this, guys. Just try to simplify this whole part under the square root. Only this part that is under the square root. So it was going to be minus 7 plus or minus the square root of what? It was going to give us 289. This whole part was going to give you 289 over what? 2 times 3, which is 6. So separating these, guys, we can now have our two answers. From the positive, we are going to have 5 over 3. From the negative part, we are going to have our x as what? Negative 4. So these were the possible values of the x that is being represented there. From the x that is being given as a number, just a normal number. That is the x that we can have. So let's do revise as many questions, guys, to be important. Another part, we are given solve for x, algebraic equations there. Factorization has to be done, this and that. All right, so let's figure out 3 over x minus 1. It is, okay, it is written properly, that one. So I'm just going to write this one, 3 over what? So this is 3 over x minus 1. Okay, that's x minus 1. Then moving on to this part, it's minus. Okay, so you're going to subtract this part here, which is a quadratic expression. Let's just factorize that, guys. Let's just factorize this. Remember, the coefficient of x squared, there is x squared minus 4x plus 3. Coefficient of x squared is what? 1. So it simply allows us to have the two brackets where we're going to have x and x here. Direct x times x squared. What are the products? Factors of what? Of 3. But these products must add up to negative 4. Products of 3. 3 and 1 minus 3 and minus 1. Multiplying these two, we get a positive 3. But when we add now, we must get a negative 4. Which part? When we add, we must get a negative 4. It's minus 3 and what? Minus 1. So that's minus 3, minus 1. Then here, be careful here on that part. They will always try to bring something that will let your marks down, guys. That minus 1 over 1 minus x here, if you do not take care of it here, was going to affect a lot of things. Remember, these brackets that we have, they are similar. They are not the same. X minus 1 and 1 minus x, they are not the same. These ones, they are the same. X minus 1, x minus 1. They're exactly the same. X is positive, 1 is negative. But in this situation here, x is what? Negative. So we must change that one to a positive. And I said, for you to change this one to be this one on minus x, it also affects the sign here. Once you change this sign here to be a positive, to write it as x minus 1, remember we want it to be written like these other brackets. Once you do this, guys, it affects this sign. So just change the sign, change bracket, just like that. Guys, let's just take it that way. It's gonna be easier. So once you change this bracket, this one, to be like this or to be like any other bracket, change bracket, you change the sign. So it's gonna be plus 1 over what? We have changed this. It is now x minus 1. Just like that. They are the same now. Not to say we work with something that is similar in a case like this. No, guys. We work with the same brackets, not similar brackets. So that is why we have to get rid of one which is similar to another to be the same as others. Now we can clear our fractions. Remember, this is your simplification. Now we can even add, guys. As you can see, these two can be combined together. These two. 3 plus this 1 here was going to be 4 over x minus 1. It's the same denominator. But if, let's say, you did not recognize that, it's fine. Clear the fractions. X minus 1, x minus 1, x minus 1 is common. Do not repeat that one. It is just common. X minus 3, it will be part of our LCM. So we multiply by the LCM, x minus 1 into x minus 3. Do not repeat the x minus 1 because it is what? Appearing once. We do the same thing here, x minus 1 into x minus 3. Like I said, we could have combined that one, but most of you guys in exam, you don't recognize this. You only realize this when I'm saying it like that, like now. Then you'll be saying, why can't you do it? All right. Just gonna put the way that you guys normally do in exam so that if anything happens, you just do that way. You won't even go wrong, even if it is like that. Okay? So do not worry about that. So x minus 1 cancels. We have got what? X minus 3, which is to be multiplied to 3. So this is 3 into x minus 3. Minus, there's a negative here. This one and this one was going to cancel. This one and this one was going to cancel. So we remain with what? 1. So that's negative times 1, which is negative 1. On this part again, x minus 1 cancels. You are left with what? Plus 1 into. There's a bracket there of what? X minus 3. This is equal to this part of our right-hand side, which is being multiplied by 1. So that simply means we need the two brackets as they are, these ones. So the job now is to expand brackets, collect like terms, and see the type of equation that you're going to have thereafter. All right? So that is the case, guys. Expansion of brackets here and also here, and these two that we have here. So what are we going to have at the end? All right. So here we're going to multiply by 3. 3 times x, 3x, 3 times minus 3, negative 9. The negative 1 is not even affected. Just rewrite as it is, negative 1. This bracket is affected by the positive 1. So that is the one that is going to multiply. So positive 1 times x, that's positive x, positive 1 times 3, negative 3. That's equal to this. Expanding the brackets, the x to the x, remember your concept, that would be x squared, your FOIL method, x to minus 3, that's minus 3x, we are done with x. Minus 1, multiplies everything, minus 1 times x, that will be minus x, minus 1 and minus 3, that will be what? Positive 3. Collect the like terms on the left-hand side. 3x and x. This is 1. So it's 3 plus 1, which is 4x. Minus 9 minus 1 minus 3 was going to give us what? Minus 13. So 4x minus 13 is equal to what we are having on the right-hand side. By simplifying our right-hand side, we're going to have x squared minus 3x. This is minus 1x. So it's minus 3 minus 1, which is minus 4x plus what? Plus 3. A quadratic equation again, remember the format. One side must be equal to 0. Ax squared plus bx plus c is equal to what? To 0. So one side must be 0, your quadratic equation. So you can take these two to the other side since we already have the x squared as a positive. So do not change that x because it's the x squared, it's already positive. So leave it where it is there. So it is going to be 0 is equal to x squared. The 4x to the other side, it will be what? Negative 4x. Remember, it was positive here. So you take it there, it will be negative. So that's minus 4, which is minus 8x. Same thing, the 13, we take it to the other side. It was positive. So simply add 13 both sides. So meaning to say, we are going to have what? 3 plus 13, which is what? Which is 16. So this is what we're going to have. We worked with a similar factorization of this nature. If you still remember, guys, the one that we had on those was question 2, which had exponents, but it gave a quadratic of this nature. But do not worry, guys. Just save your x squared minus 8x plus 16 is equal to 0. Remember, if a is equal to b, I can also write b is equal to a. So just starting with what? The quadratic so that we can properly see our equation. By factorization, this is 1. So meaning to say I'm just going to have x and x here, x times x. That's what? X squared. Then I consider what? The factors of what? 16. Remember, your constant. But these must add up to negative 8. They must give us negative 8. The products or the factors of 16. Negative 4 and negative 4. 4 and 4. Which part here? Because if we multiply, truly we get a positive 16. If we multiply, truly we get a positive 16. But which part when we add now? The question is when we add, we are going to get what? A negative 8. When we add, that's negative 4 and what? Negative 4. This is where we get what? A negative 8. So that was going to be negative 4, negative 4 like this. One of these brackets must be equal to 0, guys. It's the same bracket. So x minus 4 is equal to 0 or what? X minus 4 is equal to 0. What are you saying? X must be 4 or x must be 4. This is what you're saying. All right. Just like that. So guys, let's do just, what can I say? It's not that much. Maths and 3 is not that much. Into our factorization, solving of equations, but you see that the core part here, it has been factorization. Played part here. Same factorization, it played part here. We had a part where factorization was playing a part. The same factorization was the one that was playing part on the first party on 1.1. It's all about factorization, what you're seeing there. So do revise. Do work out more on your basics. Like I said, now there are different methods, guys, ways that can be used that you'll be some they even call them the cheat methods that they can even to use to simplify those factorizations, depending with the way that you understand. So on question 4, let's see which is part of our geometry. Just gonna consider this one, fig 1 below. So this is the first diagram, all right, that we have PQ and also R is given as an unknown point XY. So these are points in a Cartesian plane. The point M is the midpoint they actually mentioned. So read this information, guys, all right? So they are saying it is the midpoint of what? Of QR. All right, so this is it. And our diagram is going to be something like this. So this is where we have what? Our M, the midpoint of what? QR, the line QR. M is the midpoint. So this one is just direct like that. Our x-axis, as you can see, this is the x-intercept of QR, the y-intercept of PR, the x-intercept, this and that, and also the other points that you are given. And the point R is just given as an unknown point is XY like that. So the question was, let's quickly go through our questions. That is 4.1. The angle of inclination of PQ with the positive x-axis. Remember, definitely when we are referring to the angle of inclination, it is between the line and the x-axis. So the angle of inclination of what? PQ. PQ, this is our line PQ, this one. And the x-axis, remember, this is just going to be an extension, guys, like this, all right, on your x-axis. This is our x-axis. So if you extend this line PQ like this, it was going to be like this. This is our line PQ. So it meets with the x-axis at a certain point. Where it meets with the x-axis, the angle between, it is between the positive side of the x-axis and the line. It is not just between the line and the x-axis you end up calculating this angle, this one. No. It is between the line that you are given and the positive side of the x-axis to the right side. That is the angle that you consider this one. So this is our angle of inclination. So considering this angle of inclination, you can just call it beta, all right? I'm just going to call it beta. You can call it theta, whatever that you want. Just analyzing this angle, we can see that this is an obtuse angle from our angles, all right? This is an acute angle. This is the presentation of what? An obtuse angle. An obtuse. It's an indication of what? An obtuse angle. It must be an obtuse angle, this angle. All right, so guys, remember your angle of inclination from your formula sheet. If you've forgotten, you're also given the information about the straight line here. Considering that you are calculating the angle of inclination, all right? Theta is equal to arctan M. So let me just use theta, guys. Most of you are using the formula sheet. You want to use as it is in the formula sheet, all right? Let me use theta, no problem. So it's arctan of what? Arctan of M, where M is what? Where M is the gradient. So that is the case of what? Your question. So we are simply going to use arctan of M, arctan of the gradient, all right? So you call it theta, you call it beta, whatever that you're given. So this angle, in my case, like guys, I've already used beta, do not worry. So my angle beta, which is the angle of inclination, is equal to arctan M, arctan, the gradient. This M, it is the gradient. So it must be the gradient of what? The gradient of the line PQ, because we are calculating between the line PQ, right? And the x-axis. So it's what? The line of PQ. So do we have the gradient? We do not have, we are not given. So we must calculate the gradient of PQ first. Then we substitute there and also analyze your question, because I said it's an obtuse angle. So you must analyze your final answer. You must have an obtuse angle. All right. So let's find the gradient, guys. Remember, gradient change in y over change in x. All right. So that's it. So the gradient of PQ, that's y2 minus y1 over x2 minus x1, where here y2 is what? 2 minus y1, which is 4 over x2. That is 8 minus x1 here, which is what? Which is 2. So that was going to give us the gradient of the line PQ, which is minus 1 over 3. So take note, guys, the minus 1 over 3 there, it is showing us something. If you were to use it here, I want you to see, this is going to be arctan of your gradient. You calculated your gradient 1 over 3. It was going to give you a negative there. That was going to be negative 18,435, like that. So in actual sense, don't use that angle. Don't use the negative there. Just know the negative there, it is simply showing tan. Tan is negative as an obtuse angle. The tan of an obtuse angle, let's say one angle which is obtuse, for an example, 145 degrees, it's an obtuse. The tan of this, all right, my calculator is in radians. I don't know which class was I doing. Let me change back to the degrees, all right, on number 3. So now in degrees, the tan of 145, an obtuse angle, this one, we must get a negative answer there, as we can see. In the same sense, if I am to calculate the tan of 45 degrees like this, it is an acute angle. We must get what? A positive, because it's an acute angle, this one. We get what? Positive. So that is why we are seeing a negative there, this negative. It is because of the tan. Remember, it's an obtuse angle. An obtuse angle lies in the second quadrant. And in that quadrant, tan is what? Negative. But do not worry, guys, about that. Just know that your answer must be obtuse angle. An obtuse angle is an angle that we take which is greater than, it must be greater than 90 degrees. If you're talking about obtuse angle, it must be greater than 90 degrees, but less than what? Less than 180 degrees. So is this angle in that interval? No. So how can we obtain the angle? This one that you obtain the negative, it is simply this angle that we have here, the acute angle here, 18,435. Ignore the negative there. This is the angle that we are seeing, this acute angle. So how do you find this one? The exact angle, which is our beta, the obtuse. So therefore, our beta, which is the exact angle, is supposed to be 180 degrees minus 18,435. We are supposed to remove this angle from what? 180 of a straight line. That is our case. So in this case, we're going to have our beta, which was going to be 161,565 degrees as our angle of what? Inclination. Just like that. So these are your typical questions, guys. Just make sure I go through your questions again. 4.3, we are given, sorry, that's 4.2. The values of x and y. The values of x and y, if M is the midpoint of QR, as we are given before, that M is the midpoint of QR. So what will be the values of what? Of x and y. So guys, we can simply use the midpoint concept because we are already told that we have a midpoint. Remember, from our midpoint, to calculate the midpoint of a certain point, you add the x values together, x1 plus x2 over 2. The y values together, y1 plus y2 over 2. So in our case, this is what we are going to have. To have the midpoint, this M, how we are supposed to have it in actual sense. All right? M was supposed to be calculated from x1, x2, x1 plus x2 over 2. Y1 plus y2 over 2, because it is what? It is a midpoint. And we have that midpoint. All right? So change these ones, guys, into improper fractions, all right? So that at least, or you can even decimals. 3.5. All right, this one, which is same as what? 7 over 2. All right, this is our calculator. How do you work out a mixed fraction? This is another part most of you guys have a challenge. A mixed fraction like this one, 3.5, you use this one, the one on top, this. So it's shift, you press this, it gives you the part of a mixed fraction. So it's 3.5, 3.5 like this. So that is what? 7 over 2. So this is simply 7 over 2. The same with minus 2.5. Minus 2.5. Minus 2.5 like this. It is what? Negative 5 over 2. All right. So that's negative 5 over 2 so that you can properly see the numbers that you're working with if they are like this. So this is how you calculated the midpoint. You took the x from the points because it is the midpoint of what? These two. The midpoint of these two, R and what? And Q. So you took the x value here on Q. All right. This is how you simply did this part, guys. You took the x value there on what? On Q, which is 8. Added to the x value of R there, which is our x value is what? It's x. We do not know that one is x. You divided it by 2 like this, exactly as you see it on the formula. And this is what you got as your midpoint, as a numerical value. You got what? 7 over 2, because you're already given the midpoint. It's there. So you work it the way that you're supposed to work for the x and equate to the x that you have on the midpoint. Already you're given that, which is what? 7 over 2. The same thing, you're going to apply it for the y part. The y of q, which is 2 in this case, plus the y here of r there, which we do not know, over 2 is supposed to give us what? It is supposed to give us negative 5 over 2, just like that. So you've got two equations. Let's solve. Yes, you can cross multiply, guys. It's up to you. But I said when you're solving equations, guys, if the denominators are the same like this, they're the same. Just equate the numerators. Simple like that. 8 plus x is equal to 7. So what is our x? The 8 to the other side was going to be what? Negative there. It was a positive here. So simply subtract 8 both sides. So that is minus 1. Same thing, we can see it here. The denominators are the same. Cancel them. Equate the numerators as they are. So it simply means 2 plus y is equal to negative 5. So 2 to the other side was going to be a negative 2. So meaning to say y is equal to what? Negative 7. Just like that. So as a point now. All right. So the question here was just calculate the values of x and y. So these are the values of x and y, guys. We're done. Our x is this, our y is this. But if you want to write this as a point, it simply means our point R, our x is what? Minus 1. That's our x. What about the y value? Our y value is minus 7. Does it also make sense? The side where we find this x, does it make sense where we find this R here? Is x negative here? Yes, x is a negative. Is y negative? Yes, we are in the negative side. So it does actually make sense. So this is how we're supposed to find this, guys. Just like that. From the midpoint, you calculate as if, let's say the question was, calculate the midpoint of this. How were you going to calculate the midpoint? You calculate it in the same manner. The length of PQ, so the length of PQ, it is also a direct part from the distance, all right? From the distance that you are given of a line, the difference, the square root of x2 minus x1 squared plus y2 minus y1 squared. So we can use what? The distance formula. That is to calculate what? To determine the length of a line. So in our case, the length of what? PQ. PQ. All right. So let's figure out where we have P and Q. P and Q worked with these ones before calculating the gradient. So we can simply use those same way that we named x1, y1, x2, y2. We used P and Q, remember, before. So that's 4.3. So simple like that, guys. We can calculate our length. It is direct from our formula. So meaning to say PQ from the length or the distance of a line x2 minus x1 squared plus y2 minus y1 squared. I'm going to substitute the x2, which is 8, the x1, that is 2. So that's 8 minus 2. 8 minus 2 squared plus y2 minus y1, y2 here, and this is our y1. So that's 2 minus 4 squared. So simplifying this, we can even try to simplify stage by stage from our calculator. That's 8 minus 2 squared. Just open a bracket here. 8 minus 2 squared. All right, that's 36. So that was going to be the square root of 36 plus 2 minus 4 squared, 2 minus 4, then we square this. That was going to be positive 4. All right, so adding this to 36 plus 4, that's 40. So you can leave it like this. In simplest form, the square root of 40 is what? That's 2 square root of 10. This is 2 square root of 10. So take note there. We can write our answer as 2 square root of 10 in simplest form. So this is 2 square root of 10 units. This is the length of a line, or you can have it as a decimal. Change this SD here. It's going to be 6,32 and to 3 decimal places. That's shift, go to the setup. Let's fix on number 6. 3 decimal places, press 3. So it was going to be 6,325. So you can also have this as what? 6,325 units, or you can just leave it as this. All right. So this is what you're supposed to have there. The length of PQ can be determined. All right. Let's figure out question 4.4. The equation of the perpendicular. Take note. I explained the other part. I think it was supposed to be the previous one for August exam, where they said calculate the equation, determine the equation of a perpendicular which passes through. You were given a point where it passes through. All right? You were given a point where the perpendicular passes through. Take note, guys, what I'm trying to say here. You were given a point where the perpendicular passes through. But in our case, it's a perpendicular bisector. Bisector. All right. Okay, I'm still having that question. I'm still figuring out how it was. It was like this. It was calculate the equation of a line segment. It was like this through. I want you to see the difference. That's why I'm bringing this. The question was, you are supposed to find the equation of a line which through what? The line segment through P, which is, I want you to see this part, which is perpendicular to QR. All right. That was the case. It is perpendicular. The part of the perpendicular is there. Being perpendicular was there. But there it was a condition that it must be perpendicular to QR, where you have Q and R like this, passing through P, meaning to say you must have a certain point P there. You are given the point where it is going to pass. Where it is going to pass. So you take the advantage of the line QR, the gradient. Remember the perpendicular lines concept. That one we'll see it later on. There is nothing other important part. It passes through P. But in our case, we can see that we are not told here where the line is going to pass. They said the equation of the perpendicular bisector. Bisector. That is why they are not telling us to say it is going to pass through the point P or it is going to pass through the point what? It is because the perpendicular line that we have, which is the perpendicular of what? Of PQ. It is not a normal perpendicular bisector. I mean, it is not just a normal perpendicular line. It is a perpendicular bisector, meaning to say it divides the line PQ into equal parts to the foot of this perpendicular here, to this point. From P to this point is the same as from Q to that point. That is what it means. So meaning to say the point that you'll be having here becomes the midpoint, which the line is going to pass through. So the line, when it is like this, it passes through the midpoint. So it passes through the midpoint. It passes through the midpoint. That is the case. The equation of the perpendicular bisector, that this one, it will pass through the midpoint. So you are now given the point. It is the midpoint. Here, it is because it is just a perpendicular line. It is not a perpendicular bisector. They said, which is perpendicular to. The line is perpendicular. It is just meeting at 90 degrees. There is nothing special. It is not a perpendicular bisector. So they must give you a point where the line is going to pass through so that you use it to determine what? The equation. Be careful about these two questions. They will be similar like this. Another one, it is a perpendicular bisector. Another one, it is just a perpendicular line. So when it is a perpendicular bisector, like I'm saying in our case, compare this one with August 2024 exam. All right, it can make sense from there. I explained the video, so it can make sense from there. In our case, the midpoint is part of what? Of our line. So it is the midpoint of what? Of PQ. This is PQ. Let's get to our line PQ, PQ, PQ. All right, this is where we have the line PQ here. All right, I'm just going to remove this so that we try to make sense of our question. So this is our question, guys. It simply means from PQ like this. This is our line PQ. The line is a perpendicular bisector of PQ. The line is a perpendicular bisector of what? PQ. So what it simply means, it is dividing the line PQ into two equal parts. This perpendicular bisector will divide into two equal parts. So we must have here the midpoint of PQ. We must use the midpoint. It passes through what? The midpoint. So how do you find the equation, guys? That is our question now. How do you find the equation? Remember, that's 4.4. So to find the equation, we are going to need the gradient and also a point where it passes through. So the gradient of PQ, if I'm not mistaken, all right, the gradient of PQ, we calculated this one, if I'm not mistaken. It was PQ, this one, yes. We calculated the gradient of what? Of PQ. But as we need the gradient of this line, not the gradient of PQ. So what is the relationship? Remember, if lines are perpendicular, the product of their gradients gives us what? -1. Perpendicular lines, the product of their gradients. So meaning to say, the gradient of the line that we want to calculate, in this case, which is our M, times the gradient of PQ that we calculated, we must get a -1 because they are what? Perpendicular lines that we are talking about there. So the gradient of the line that we want to calculate times the gradient of PQ that we calculated minus a third is supposed to give us what? -1. So what is the gradient of the line? So divide by -3, by -1/3, by -1/3 both sides. So that was going to be the gradient of the line. So that was going to give us +3, guys, by just looking into this, or you can just calculate. So this is our gradient. Remember what we need. We need the gradient. So M is there. No points. We are not using points there. We do not have any point on this line. Remember, this is our line. There is no point there that we can use. So we have to consider the relationship of the lines. They are perpendicular. All right. After that, we need a point. All right. So remember, like I said, we need a gradient. So the gradient is there. What else do we need? We need a point. So where are we going to have the point? The point in our case, where our line passes, is what? Is the midpoint of PQ. So our point is simply the midpoint of what? The midpoint of PQ. Since it is a perpendicular bisector. So we are simply going to calculate the midpoint of PQ. Remember, guys, how you were calculating the midpoint. All right, you add the X values together, the Y values together. So it means the midpoint of our line PQ. All right, the midpoint of our line PQ is going to be what? Add the x values, 2 and 8. These are the x values, 2 plus 8 over 2. Add the y values together. That's 4 and what? And 2. So that's 4 plus 2 over what? Over 2. These are our y values. So you're going to have the midpoint of PQ, which is 5, 3. So it was going to be 5, 3, 6 over 2, which is 3. So the midpoint is our point that we are going to use in determining the equation of this line. So having a point, having the gradient is enough for us to determine what? The equation. So using the gradient intercept format, here we are not given to say, leave your answer in this form. So you use any that you understand. So I'm going to use y is equal to mx plus c, where m is the gradient, and we have it. M is what? 3. So y is equal to 3x plus c. To find c, substitute the point, where our point is what? Is the midpoint of PQ. So y is what? Is 3. When our x is what? When our x is 5. Plus c, like that. So that's it. 3 is equal to 3 by 5, which is 15 plus c. Take the 15 to the other side. It was going to be negative. That's 3 minus 15, which is what? Negative 12. So that's negative 12 is equal to c. So therefore, our equation was going to be y is equal to what? From here, we have got what? 3x plus c. Our c is what? Negative 12. So that was going to be a negative there that we have at the end, which is what? Negative 12, just like that. Just like that. So we're given a certain condition, perpendicular bisector. So for 5 marks, yeah, that's it. All right, let's see another one. They are saying here, the equation of mn. In this form, there we are given a format to use. So you can work with y is equal to mx, then your answer, you change it there. Do not worry about that. But let's worry about the question. The equation of what? Mn. If, this is the most important part of our question here. If Mn divides PR and QR in the same ratio. In the same ratio, it divides QR and this PR and QR. All right, let's check the line MN. Where is MN? M, all right, we just have M here. We do not have N, all right? Let me remove this. It's gonna, if we need it, guys, we're just gonna recall. So this is where we have M. We do not have N, all right? Sorry, I'm gonna need 1 or 2 of this. I'm gonna need 1 or 2. All right, let me see. Okay, this is where we have M, remember. So they are saying the line is MN. So we are going to have a line like this, MN. But the line as we are drawing, it is not going to be like this, or it is going to, because they are saying it is going to divide. The line MN, it divides which lines? PR and QR. P to R. This one. PR and this one, QR. They are divided into the same ratio. Which ratio is that one? Where do we know the ratio, or how can we know the ratio? M, remember, represents what? The midpoint. So as it divides from here to another part, which is N, because the line is MN, MN is our line, M to N, all right? M to what? To N. They are saying it is dividing in the same ratio. This is the question. MN. Take note, N is not there. So it is us who was to bring that N. So the line MN divides PR and QR in the same ratio, meaning to say the same way that M was dividing here. How was it dividing? It was dividing as a midpoint, meaning to say also N is dividing that P R there as a midpoint, it is dividing into two equal parts, just like what we have. So it is also a midpoint. That is what it means. This N that we see, it is also a midpoint. That is our case. So guys, they were hiding something from this statement by just knowing this. They were hiding a very, very, very important aspect of our mathematics here. There is no way that a line is drawn like this in our case. There is no way that a line is drawn like this. And it passes through the midpoint and also to the midpoint there. There is no way unless these two lines are parallel. So it is referred as the proportion. But in our case, it is the midpoint. All right? It is the midpoint concept, the midpoint theorem. If you are given a triangle like this and a line is drawn parallel to this one like this, passing it, this line that you have drawn, it will be passing through the midpoint. So we must be specific about this. It is passing through the midpoint. These two be parallel. So it's a proportion part which can be used if it is having like a certain proportion. It is not only the midpoint, but in our case, it's a special type of a proportion theorem. It's a special type because it is passing through at the midpoint. But knowing that they are being divided, let's say it was not a midpoint, this statement alone, this one, the statement here alone here, to say MN divides a certain line and another line in the same ratio. That statement alone, it tells us that the line that is dividing in the same ratio and another one on the base or whatever that you have there, they will be parallel. It might not be at the midpoint, but they will be what? They will be parallel. So that was our case. So knowing that these two lines are parallel, guys, what is our advantage in determining the equation of this line? What is our advantage of determining the equation of what? Mn. Remember the equation there is to determine the equation of what? Mn, this one. We are simply going to take the gradient of PQ because they are parallel. And if lines are parallel, what is it about their gradients? Same gradient. Parallel lines, they have same gradient. So that is the condition there that we are going to consider now. To say, since Mn is parallel to what? To PQ from that proportion concept. Therefore, the gradient of the line Mn must be equal to the gradient of the line PQ. We calculated the gradient of PQ before. PQ, remember this was the midpoint. Okay, I erased that one, but I still remember. We calculated it was minus 1/3, if you still remember. We calculated that one. This was negative 1/3. So meaning to say, that is our gradient for the line MN. It has the same gradient as what? As PQ. So knowing the gradient of Mn is enough, guys. Remember, when you want to determine the equation, I said, what is it that you need? You need the gradient and you also need what? A point. So in our case, the gradient is there. What about the point? The line Mn, does it pass through any point? Yes, it passes through M. It also passes through N. You can calculate N because they are saying N from that concept, if it is the same ratio, it means it is the midpoint of what? Of Q of PR, this one. So you can also calculate the midpoint of N. But why bothering, guys? While M is there. So this will be our point. So the point is there. So let's find our equation. Y is equal to mx plus c. Yes, they told us to use a certain format. That one is the final answer. So you can use this or you can use this one there. Okay, there's this one of y minus y1 is equal to m into x minus x1 like this. Guys, it's the same. Do not worry about this. So we have y minus y1, which is on our point. So y1 is what? Minus 5 over 2 is equal to m. M is the gradient. That's minus a third into x minus our x on the m there is what? 7 over 2 like this. All right, so this is it. If you are using this way, you are simply going to expand. All right, that's minus minus is positive. 5 over 2 is equal to minus third times x. That's minus a third x minus a third times minus 7 over 2 from your calculator, guys. That was going to be positive 7 over 6. All right, then we take the 5 over 2 to the other side, or we simply subtract the 5 over 2 so that this can cancel here. So y is equal to minus 1 over 3x, 7 over 6 minus 5 over 2. Let's see. Okay, remember we fixed our calculator, guys. Let's bring back to the normal mode. Press 8, press 2. All right, that's we need to subtract this 7 over 6 minus 5 over 2 minus 5 over a 2 like this. So that's minus 4 over 3. So you're going to get minus 4 over 3. So this is what I want you to take note. If you were using, or if you're working with y is equal to mx plus c, you are simply going to have these guys. But I just want you to know different ways of what having your equations. Whether you worked from here, you are going to have your equation like this. You worked from this one, this is what you have. But this is not the format that they're asking. Whether you used this one of y is equal to mx plus c, definitely you are using a format which is not asked here. But let's figure out now, according to our format, what are they saying? They are saying our answer is supposed to be in the form of ax plus by plus c is equal to 0. We are supposed to take all these to one side of the equation. One side must be equal to 0. Where a, b, and c must be integers. A, b, and c, these constants must be what? Must be integers. Please take note. Not the fractions to say you take this one, the minus 1 over 3, this side, it becomes a positive 1 over 3x like this. All right. Since we start with x, we follow y. Y is what? That's a positive y as it is like this, positive y. Then you take the minus 4 over 3 this side, it becomes a positive, positive 4 over 3 like this. Then you say it is equal to 0. Transposing these to the other side of the equation so that we have x and y and a constant like this is not enough. A, b, and c must be integers always. Not like this. But this is exactly the same format, guys. Look, we are starting with x. This is x. We move on to the part of y. This is the part of y. This is a constant. This is a constant. The other side is 0. The other side is 0. Where are we going wrong? Everything is fine. But only that a, b, and c must be integers. And they don't even mention that for you. You're supposed to know it in this format. All right. So how can we make this to be integers? We find the LCM of the given denominators, or the LCD of the given denominators. This is the same as over 1. Remember, this is the same as over 1. So what is our LCM, or the LCD of 3, 1, and 3? That's a 3. So we're going to multiply each and every term by 3, each and every term by 3, each and every term by what? By 3. So 3 and 3 was going to cancel. That's a 1. That's 1 times 1, which is 1. 1 times x, that's x. All right, 1 into 3, that's 3 times y, which is what? 3y like this. 3 and 3 was going to cancel. That's a 1. 1 times 4, which is 4, is equal to 0 times any number. That's a 0. So this is what you're going to have at the end. Same format. So this, the coefficient of x there is what? It's 1. So this is our a, our b, our c. Where a, b, c are what? Integers. Just like that. So it is very, very important to take note the format that you are given. It is not just answer the question. The format that you are given is important. Very, very important. All right, so that's it, guys. 19 marks for this. Okay, let's figure out another part. Question number 5, we are given to draw this graph in the answer book. Let it be in the, and they are actually showing you guys very, very important to say it must be done in the answer book. Showing the turning point, axis of symmetry, intercepts of both axes where they exist, if if any of these exists. So what type of a graph are we having there? That is the first thing for you need to ask yourself, that what type of a graph is this one? So we are given x over 2, x over 2, guys, what am I even saying? X squared over 4. Okay, this is working with a tired mind now. It's tired, guys. Let me just try to finish up. We think almost there. All right. Yeah, okay. We're still there. We're still there. No problem. Let's see. So this is okay. I wanted to see there. Now it does not want to go back. You see now. All right. This is it here. So if we are to check here, what type of a graph are we having? If we are to consider, this is simply an ellipse. An ellipse is similar to a circle. It is similar to a circle. The difference that we are having here is on the denominators. If these denominators were the same, like let's say it was x squared over 4 plus y squared over 4, like this, is equal to 1. If these denominators were the same, that was going to be what? A circle. If they are different like this, it becomes what? An ellipse. So we are working with what? An ellipse there. All right. So remember, I talked about sketching of these graphs, guys, drawing of these graphs. An ellipse and a circle, they are similar, very, very similar. Even the approach on how to draw them, it is just similar. Your x-intercept and what? Your y-intercept. What are the conditions for the x-intercept? That is what you need. Y is supposed to be what? Y is supposed to be 0. So when y is 0 here, when y is 0, it means, yes, there is nothing there. 0 squared over 16, there is nothing here when y is 0. So you are left with x squared over what? Over 4, which is equal to what? Find the values of x. So cross multiply, x squared is equal to 4 times 1, which is 4. Introducing the square root to get rid of the square. So x will be the square root of 4, which is what? Plus or minus 2, just like that. So for the y-intercept, guys, we are going to simply do the same thing. That is, for the y-intercept, the conditions this time will be x must be what? X must be 0. A part of x here, this x must be 0 here, this one. So meaning to say you'll be left with what? This part. Y squared over what? Y squared over 15 is equal to 1. Over 1 cross multiply, so y squared is equal to 15. Just like the previous case, guys, introduce the square root. So y is equal to the square root of 15. So guys, we cannot simplify the square root of 15 just like square root of 4. So you can even leave it like that, plus or minus the square root of what? The square root of 15. So this is just like a sketch. We cannot have this number, guys, on our graphs. Let's say square root of 15. This is what? 3.87, well, something like that. So we just approximate. It's just a sketch, as long you know the graph, how it is supposed to be like. How does it look like? How does an ellipse look like? Given the x-intercept and the y-intercept. As we saw there, the y value was 3 points. So the y is bigger than the x value. So just gonna have something. You're going to end with something like this. I'm just gonna put something. Sorry for that. Your y-axis and your x-axis like this. All right, so we've got 0 here. So as you can see, our x is at positive 2 and minus 2. So this is something like this. Then the y value, square root of 15, something like 3, comma, something like that. Let's say this is where we have square root of 15. Down here, we are going to have what? Negative square root of what? Negative square root of 15. So that's it. We draw our ellipse. So that will be at minus 2 to minus 15. Remember, we need what? Minus 2 here, minus 2 and minus 2. So this side to positive 2 to the minus 15 like this. So it is just similar to a circle, but not a circle. This is an ellipse. So that's the difference from the center to another point, from the center to another point is different. All right. It's just like we're having different radii. All right. We're supposed to have the same radius. A circle is supposed to have the same what? The same radius. So that's it. We have got our graph. So remember our x and y axis, just like that. Then on another part, 5.2, determine dy dx derivatives. You're supposed to differentiate by the means of the rules of differentiation. Which rules do we have under differentiation? Under the derivatives, we just know that if we are given x to the exponent of n, we can differentiate that by dropping the exponent and subtract 1 on the exponent. We drop the exponent, we subtract 1. That is the part that we understand. So we must have that format of x raised to a certain exponent. X being raised to a certain exponent, all right? So let's just try to rewrite. And also your final answers, they're saying leave the final answer with what? Positive exponents. And insert the form where applicable. Show all the steps. All right, so let's just take our part as it was our question. So that's 5.2. So it was something like this. Y is equal to the square root of x over 2 plus this is 2 over the fourth root. So this is the fourth root of x. It has nothing here. It's all about your exponents. We are supposed to have x raised to a certain exponent. This is our case. So let's start with the square root. The square root means what? From our exponents is to the exponent of a half. Everything over 2. Plus, this one is 2 over the fourth root means what? Just like the square root. The fourth root, the number inside is 4. So that's x to the exponent of 1 over the number that is inside the root. So here it was a 2. Inside here, there's a 2, which is hidden there. But still here, we still have a complicated because the x is in the denominator. We are not supposed to have it in the denominator. We're supposed to have it as an x as it is, properly. So we must take this one on top here. How do we bring it on top from our laws of exponents? Just like this one, which is on top. It's already on top. There's nothing that we can do. We just have to leave it like that. But remember, guys, I said x over 2 is same as half of x. So knowing that we've got x to the exponent of half like this over 2, it also tells us that it is the same as I can write it as like this, half x to the exponent of a half. I'm not differentiating. I'm just rewriting like this. X over 2 is same as what? Half of x. If you are given x over 4 and you are writing 1 over 4 of x, nothing has changed. One and the same. So this is what I'm trying to say on this part. That's how you can just simplify like as. Then this one, you take this one on top. Remember what I said? Once you take it on top, it takes what? A negative. 2 is already in the numerator, so you leave it there. But the x here will carry a negative, so it will have a negative what? Exponent like this. That's our case. Then we can differentiate. Now we can use this concept to drop the exponent, subtract 1. Derivatives. If you are given this ax to the exponent of n, the derivative of y with respect to x, it will be an x to the exponent of n minus 1. You drop this one to multiply the number that is here. Then you subtract 1. This is the case. You drop it down. So it will be half times a half when you drop it. Then you subtract 1 on it. On top of it, on that, you subtract 1. So what is half times half? 1 over 2 times 1 over 2, that's 1 over 4. We are now finding the derivative when we are doing this. That's the derivative. We are now differentiating. Drop this, we subtract 1. So that was going to be 1 over 4. X to the exponent of what? Half minus 1. That's a minus half, a minus 1 over 2. All right, we move on to the other part. We do the same thing. Drop the exponent, subtract 1. So this is the case. We drop this exponent there on a 2. We drop it. This minus 1 over 4. So it's times minus 1 over 4. We subtract 1 on that exponent as it is. We minus a 1 like that. So 2 times minus 4, that's a minus half. If you simplify this properly, that's a minus half. Minus 1 over 4 minus 1, that's minus 5 over 4. So it was going to give us what? Minus 5 over 4 like this. So this is where you are, guys. With your laws of exponents, now this and that, we are supposed to get rid of those negative exponents. That's what they were saying. And also to leave your answer with the square root. So meaning to say it was going to be dy dx is equal to, take note, if you're writing something like this, guys, the negative there, it's affecting x. So it's just like 1 over 4. It's just like this, 1 over 4 times 1 over x to the exponent of a half. It's the 1 over 4 on its own, this one on its own. So what are we going to have? 1 times 1, that will be 1 over 4 times this, that will be 4x to the exponent of a half. We've removed the negative on what? On x. That is the same case with this one. The 2 is already in the denominator, so it's already affected. So it's 1 over 2x to the exponent of 5 over 4. Removing what? The negative exponent. Guys, this one is just a vice versa. Remember here, it was in the denominator carrying what? A positive. When you wrote it on top like this one, it was carrying a negative. So we're just having a vice versa now. From this stage here, we are now having a vice versa from this stage. Going back here. So 2 is not affected, right? 2 here is not affected. It is the x which is affected. So you just have it on its own. Just like the half, you just have the half on its own, then this one is affected. So in our case, it is because of a fraction. That's why we see these numbers in the denominator, because they are in the what? They are in the denominator, the 2, the 1 over 2. So it's like 1 over 2. Just the same way, guys. Remember also this part of your what? The square root of x here. What was this x to the exponent of half? Wasn't it square root of x? It was the square root of x. It is the one that, so it's just a vice versa. We are now going back. Remember, as I said, square root of what? Square root of x. We had this before. So it's 1 over 4 square root of x. It's just a repetition, this one that you'll be having. Minus 1 over what? Again, we have that part, the denominator into the root sign. So it will be the 4th root of the denominator. This one is the one that enters the root sign. So it's the 4th root of x to the exponent of the numerator. The numerator is your exponent. That's the case. We are done. Everything is now in simplest form, where the sets are, they are positive. Everything is now in simplest form. So you must be very careful in your simplification whenever you have this type. On another part, they want us to, okay, let's see. Are we not having a first principle somewhere here? Oh, it was not given. All right, no problem. It was just like that for this one. Then this one, 5.3, consider fig 2 below. The curve represents this function. F of x is equal to this. The curve intersects the x-axis at 0, touches the x-axis at 2, and the y-axis at 0. Okay, these are the properties of the graph, guys, as you can see here. Y-intercept, which is this one, is the origin both, and x-intercept, there's a p there, just like that. All right, so let's figure out what are they saying. 5.31, show that b is minus 4, C is what? C is 4. How can we show that? How can we show this from what we are given? All right, take note that this is a cubic function and we are given its function here. That's 5.3, where f of x is given as what? As x cubed plus bx squared plus cx, like this. This is your f of x. The properties that we do know, because there's nothing here that we can see. The only thing that we can tell is the a that is on x cubed. Remember, f of x is equal to ax cubed plus bx squared plus cx plus what? Plus d. This is the only part that we have. We just know that a is 1 because it's given. You are not given like a, b, c. If they wanted, they were going to write as a there to show that it's supposed to be another number. But in our case, it's not written. So it means a is 1. We already know that. But what about b? What about c? All right. Is there any point? Yes, there's a point 0, 0 that we have. Is the origin this one, where x is a 0 and y is a 0. Substituting this does not help, because if you substitute, okay, this is what I'm trying to say. Y is equal to x cubed plus bx squared plus cx, like this. So substituting this point to say x is 0 and y is, does not help. You substitute a 0 here, a 0 here, as what are you going to have? Nothing. So it's a point, yes, but useless, does not have anything to offer it for this point here, for this one. What about this one? Does it have any implication to our function? Yes, because there is a value there. The point is 2 what? Is 2, 0. We have the x there, even though y is 0, but x, there's something. So let's substitute that point. Normally taking as a point as it is from f of x, from f of x as it is, from f of x, as it is from the function y is equal, it's a relationship to say when x is 0, y is what? When x is 2, y is 0. That is the relationship here. When x is 2, y is 0. So in place of y, let's substitute y is what? That's a 0. When x is 2, when x in place of x is 2, 2 to the exponent of 3 plus in place of x, 2 to the exponent of 2 plus in place of x, that's a 2. So let's simplify. That's 0 is equal to 2 to the exponent of 3, that's 8, plus 2 to the exponent of 2, that's 4 times b, which is 4b plus 2c. As you can see, we have formed an equation with the two unknown values b and c. We can even reduce this equation by 2, by 2, by 2, by 2, like that. All right? So that was going to be c plus 4 divided by 2, that will be 2b. 8 and 2 was going to be what? 4. So this is equal to 0. It's an equation. On this equation, you can write it the way that you want, guys. It's up to you. You can even make C the subject of the formula. It's up to you, guys. You can even write this. C is equal to what? Because you can see that it will be easier to work it that way. Take this to the other side. Take this to the other side. So we are going to have what? Negative 4. The b to the other side, the 2b will be negative 2b. So that's an equation. C in terms of b. Can have it as an equation like that. We took this from where? The point as it lies on our function. But we formed an equation which has got two unknown values, meaning to say there's nothing that we can do for now. So what can we do, guys? We go back to this concept. The point that we used here, it's very true. It is it's a point which lies on what? On our function. But at the same time, this point that we are using, it is important here. It represents also a turning point. We used it as a normal point as it lies on the graph. It has the characteristics on its own, just lying on a graph. It has its own characteristics. But what about being a turning point? What are the conditions? the conditions are for a turning point, the first derivative must be equal to what? To 0. We are using it as a turning point now because it's a turning point. This one, it's a minimum turning point. So working it from there, from that view, we are going to form another equation. We worked from f of x. This one, we are going to work from what? From a turning point. We know that at any turning point, the first derivative with respect to x must be 0. So meaning to say, if we differentiate, what is the first derivative with respect to x? Let's differentiate. We drop this exponent. That was going to be 3x to the exponent. We subtract 1. So that will be 3x squared. We drop the exponent here. That was going to be 2bx. All right, 2bx. We subtract 1. So it was going to be 2bx. Remember cx, guys. We're just going to take what the c that we are seeing. Just like the derivative of 2x. You take what? 2. So if you're given cx, that's plus c, a linear part of mx. This is your gradient, all right? This is your derivative. That's the concept. So this is our first derivative with respect to x. And as a turning point, it still maintains the same property. It does not change. It's still the same 2, 0. The same point which we call 2, 0, it's also a turning point. So we are going to substitute it as a turning point. Y is equal to what? On our turning point, it's 0. When x is what? When x is 2. Just like the previous case, when x is what? When x is 2. But only that we are using this time as a turning point. So in place of x, substitute what? Substitute 2. That's simplify this, guys. You're going to get 12 plus 2 times 2. That's 4. So that's 4b plus c. So just like the previous case, we made C the subject. I'm just going to also make C the subject. So simply means C is equal to what? The 12 to the other side was going to be negative 12. The 4b to the other side was going to be what? Negative 4b. So this C is equal to these numbers on the other side of the equation. So this is my equation, guys. I'm going to call it equation 2. So as we can see, we have two equations that can be solved simultaneously. How were they formed is important, guys. From the point of a function, the understanding a function, that if a point lies on a function, it maintains the properties that when you substitute the x, you must get the y value. But on this one, the same point was a special point, which is a turning point, which has its own properties that its first derivative must be equal to 0. This is the condition of what? The turning point. So from there, we can solve these two equations. C, this is C. So you can simply equate this part and this part. Simply means they are equal. Therefore, minus 4 minus 2b is equal to what? Minus 12 minus 4b. So let's solve. On solving simultaneous equations, use any method, guys. Even the presentation, how you're going to present your final answers, they do not be limited. As for me, I just say C it's important to, as for me, I just saw, okay, it's going to be easier for me to make C and also C there. Use any way, guys. These are simultaneous equations. Don't be limited to say, I'm supposed to follow this way. All right. So let's solve. I'm just going to take, all right, the 4 this other side. The minus 4b this side. So it will be minus 2b plus what? Plus 4b. The minus 4 to the other side was going to be a positive. Negative 12 plus 4. Negative plus 2. Negative 2 plus 4, sorry, that will be 2b. Negative 12 plus 4 was going to be what? Negative 8. So by 2, that's our b, which is negative 4. So our b there was going to be negative 4. So from any c that you have here, you can substitute in any of these two. Whatever that you want, you can substitute the b that you calculated in this one or in this one. So I'm just going to use the first one. Remember, C is equal to -4 minus 2B. So C is equal to -4 minus 2 times B, which is -4. So that's it. Minus, minus. Use your calculator, guys. There, do not worry, guys. So that was going to be a positive. Like I said, you can even substitute here in place of B, you substitute -4. You are going to have the same answer for your C. You just have to substitute in any of the given equations. So is it the values that were being asked there? Show that B is -4. That is it. C is +4. This is what we have. So these are the values, guys, of what? B and C. All right. Just like a follow-up. It's like because you are given like so they said show. That is why they give some few marks there. But guys, okay, let's see. 5.32, calculate the coordinates of P in the so if the gradient of the tangent line of the curve at P is 20. All right, all right, all right. There's a point P here. Okay, this one. So let's read our question again. Calculate the coordinates of P if the gradient of the tangent line of the curve at P is 20. The tangent line at P, if a tangent was to be drawn here at P, it has a gradient of what? It has a gradient of 20. The gradient of this tangent is 20. So what is the equation? So the question is what? Calculate the coordinates of what? Of P. All right. So we need the coordinates of P, not the equation or what. We just need what? The coordinates of P. So we do not know these coordinates. All right. So that's so it was actually 5.31 and 5.32. There I just wrote 5.3. So this is 5.32 now. All right. The first one was 5.31. Now this is 5.32. So we need the coordinates, guys, of what? Of P. So what is the condition or what will be the conditions there? Where P is, if they say this is a tangent, I say the condition of a tangent and a curve is that the gradient expression of our curve, the gradient expression, the first derivative, represents the gradient expression. It must be equal to the gradient of the tangent. The gradient expression of a curve must be equal to the gradient of a tangent. That is the condition where we have a tangent. So meaning to say, we were going to need the first derivative from where? From our f of x. Remember, f of x is equal to x cubed plus b, and we calculated our b. Remember, they said b is -4, and we calculated that one. So it was -4 x squared. Our c, we calculated this one. It was +4. That's 4x like this. So we can determine the gradient, the first derivative with respect to x of the function. So this is from the function. This is from what? The tangent. All right. Function and a tangent. So what is our first derivative? Here we drop the exponent. That's 3x squared. We drop this one. That was going to be -8x plus what? Plus 4. This is what we have. The first derivative, this one, as it is 3x squared minus 8x plus 4, as it is, guys, as it is, must be equal to the numerical value now on the tangent, because the tangent is a linear, it's a straight line. So you'll be definitely having what? The numerical value, exactly the numerical value. So in our case, we are given that the tangent is what? The gradient of the tangent is what? Is 20. So you equate to that numerical value like this. You have formed an equation, guys, that you need to solve from this statement alone. The first derivative must be equal to the gradient of the what? The function. So let's solve. 3x squared minus 8x plus 4. You take the 20 to the other side. So it was going to be what? -20 there. It was a positive. So it was going to be negative 20. That's equal to 0. So 3x squared minus 8x, 4 minus 20, that's minus 16 is equal to 0. So guys, using your factorization, using your quadratic formula, I don't know what you're going to use, guys. We talked about this factorization. I'm just going to write my answers. We're going to have something like 3x plus 4, x minus 4 is equal to 0 using your factorization. Using anyway, use any factors that you have known, or just use what? Your quadratic formula. Here it is to solve, guys. Just solve any way that you understand, all right? So I don't want you to get limited there. So x was going to be negative 4 over 3 if we take this one to the other side, or x is what? Negative 4. It was going to be what? A positive 4. So these are the answers that you're going to have, guys. If you use your quadratic formula, or if you use any method, these are the answers that you're going to have. But where p is, can p be negative this side? Can the value of x here be negative this side? From this part on its own here, guys, from here, origin, going to the right, we are going to the positive. So this cannot be negative. X cannot be this negative value. Where p, considering the side where p is on the right side, positive values. So p is supposed to be what? At p, x is supposed to be what? 4. So we are saying at p, x is equal to what? X is equal to 4 at p. So how now do I find the value of y at p? Where is p? P lies also on this function. It lies on the function. So if p lies on this function, it means if we are to substitute the value of x, which is 4, into our original function f of x, remember your f of x when you substituted the b and the c. It means if we are to substitute it back, we are supposed to have the same answer. Remember, it was y is equal to x cubed minus 4x squared plus 4x. All right, is that so? Yeah, it was like this, x cubed. So you can substitute now, x, which is what? 4. So that's 4 to the exponent of what? 3. 4 to the exponent of 3 minus, in place of x, 4 to the exponent of 2 in place of x. So this is 4 into what? Into 4, just like this. It was going to be a substitution throughout. So y is equal to what? Positive 16 from there. Just use your calculator, guys. So at p, where x is 4, it simply means, therefore, our point p was going to be what? 4. What about the y value? Our y value was going to be 16. So that's 416. That's our point p. So, see, guys, it's just concept, math. It's just about concept, from this one to this one, from that one. It's a concept together that is to be gathered, combined together. So that was it, guys, on question 5 to obtain the 15 marks that we see there. We just needed to apply this. Use the basic trigonometric identities to prove that. Which identities can we use to prove that the left-hand side is equal to the right-hand side? So in our case, 6.1 is going to be easier, guys, to work with the complicated side, which is this side, the left-hand side. We've got a lot of things. Yes, we can work from the right-hand side. So I'm going to choose the left-hand side. From the left-hand side, we are given sine to the exponent of 4, sine to the exponent of 4 minus cos to the exponent of 4. It must give us this. How is that possible? So, guys, our trigonometry is getting extended in our N3 mathematics. They are just extending, making things difficult every time. Anyways, guys, this is it. When you are given this, you can see there is a difference of 2 squares, which is actually being hidden somewhere there. 4 and a 4. X to the exponent of 4 minus y to the exponent of 4. X to the exponent of 2 raised to the exponent of 2. Is it different with this? No. Not different. So in our trig, we can also have the same thing, guys. The sine to the exponent of 4 can be written as what? Sine squared x raised to the exponent of 2 minus also the cos squared of x raised to the exponent of 2. So that when we have this, we can note of a difference of 2 squares. This one raised to the exponent of 2. This one here, as it is raised to the exponent of 2. What does the difference of 2 squares say in our factorization? A squared minus b squared is equal to what? A minus b into a plus b. A here. This is your A, this is your B. A minus B, A plus. So this is what we have. This is our A, this is our B. So we're going to have A minus B sine squared x minus cos squared x. That's A minus B. Into what? A plus B. This one plus this one sine squared x plus what? Cos squared x. A plus B. This is our case. This is our case. So understanding this, guys, is very, very important. So if you are to consider our identities, remember they are saying use identities there. We have identities that can be used in place of one another. It is we can choose here to say, okay, this one, remember, it is an identity that we have from our Pythagorean. Let me check if you are given this part. There are some that you're given, some you're not given. So this one you're given, the Pythagorean there. Sine squared plus the cos squared gives us what? Gives us a 1. Sine squared plus cos squared gives us a 1. So if that is the case, we can simply substitute. If that is the case, all right, we can simply substitute with a 1 here. Sine squared plus cos squared, that's a 1, the whole of this part. So meaning to say we are going to have 1 times this. 1, guys, 1. This one is 1 in numbers. It's just a 1. So 1 times any number, it remains as it is. It's going to remain as what? Sine squared x minus cos squared x. This is where we are. We have cancelled. This one is multiplied this part as it is. Here it's no longer there. So this is what we have. So it is either you are going to have your answer in terms of what? X, in terms of cos, or your answer in terms of what? In terms of sine. So let's check what is that we have our answer. Our answer is in terms of what? In terms of cos. So we must get rid of this sign because our answer is in terms of what? Is in terms of cos. How can we get rid of that, guys? We said from this one, sine squared. We just make it the subject. Sine squared plus the cos squared is equal to 1. So what represents this sine squared? Because we want to get rid of this, we want to remove it. We simply take the cos squared to the other side. So therefore, the sine squared of x represents what? 1 minus cos squared. Just like that. So this is what we bring. In place of the sine squared, we are going to bring this 1 minus the cos squared of x in place of this sine squared. But already there's a minus cos squared that we have. So you're going to have minus cos squared of x. So this is it, guys. Your identities can be simplified. Cos and cos, these are like terms. So minus 1, minus 1. What are we going to have? That was going to give us 1. Minus 1 is what? Minus 2. So that's minus 2 cos squared of x. Exactly what we have on the right-hand side. So this is exactly our right-hand side. So this is it, guys, on the proof. Work with the complicated, the most complicated part. Work with that one. It's going to see that it will be very easy like that. All right, working with 6.2, that was a trigonometric equation. Calculate the value of values. The value of values of what? Of theta. That will satisfy the equation, this one. The equation for this interval, in this interval, if we are given this. Also, they do repeat this one, guys, where you form a turn from that one. They do repeat this question. 5 sine of theta is equal to 8 cos of theta. They do repeat. They can use x. They can just change the numbers here. So what is that you need? You need to formulate the tan of theta from there. That is what they just want you to form. There is nothing that they want. They want you to have this identity here. Tan of theta. Sine over what? Sine over cos. So can we have that? Yes, we just have to divide by cos. Every part divide by cos to have that sine over cos. So divide by cos of theta here. Divide by cos of theta. It was going to cancel like this. But as we need what? Here. Once we have this sine over cos, we know that it's a what? It's a tan. So it was going to be 5. This one, it gives us what? A tan. So that's 5 tan theta is equal to 8. So as you can see, guys, we've got a single trig there, which is tan. So divide by 5 by 5. The tan of theta is equal to what? The tan of theta is equal to 8 over 5. Remember your trigonometry, when you've got a single trig like this, you can find the reference angle. Since the interval is taken from 0 to 360, there we need a reference angle. If it is from 0 to 90 degrees, there's no need for reference angle. Your answer is your final answer there. But when you are given an interval from this one to this, find the reference angle. I said, guys, from our trigonometry, the reference angle is simply arctan of whatever that you're given. If it is sine, if it is cos, arc of that. But considering that you only work with the positive values. So in our case, it's an advantage. It's already a positive. There is no adjustment there. So it's arctan 8 over 5 on our calculator. Arctan, shift tan. This one, shift, you press tan, arctan, you must have a negative there. So that's 8 over what? 8 over 3. So 8 over 5, not 8 over 3, but 8 over 5. So just like that, you're going to have your angle, which is the reference angle. This is not the exact angle. It is the reference angle. Remember the reference angle, the acute angle. You're calculating the acute angle. So to 3 decimal places, that was going to be what? That was going to be 57.995. All right. So that's 57.995 like this. This is our reference angle, guys. This one, not the exact angle. For you to have the exact angle, that's where you ask yourself now, according to the tan, this one that we are given, which quadrant we have it, where tan is what? This number that we are seeing, it is what? A positive. That's a positive value there. So where do we have a tan being a positive, guys? Which quadrant is it? Where tan is positive from the cast concept or whatever way that you understand. Yeah. Where tan is positive. In the first and in its quadrant, where tan is the third quadrant. So the actual angle, which is theta, can be calculated. So therefore, theta is equal to what? Remember, in the first quadrant, theta is equal to the reference angle. You take the references as it is. So our theta was going to be 57.995 degrees, or our theta is going to be what? Another part where tan is positive in its quadrant, third quadrant. How do you write theta, the exact angle? Remember, the reference angle is here. This is where you have a reference angle. So the exact angle is this one. So you add the reference angle. 180 plus what? The reference angle. Remember, this is what I explained. So that is, we're going to add 180 degrees plus our reference angle, 57.995 degrees. All right. So this is 995 degrees, just like that. So that's our theta. Another one. 237.995 degrees, just like that. So you've got this as our theta, this as our theta. So these are the exact values. You first determine the reference angle. If there was a negative, you ignore the negative. The negative, it simply tells you where tan is negative, to say tan is negative here. and tan is also negative here. That is that is what it tells you. So when let's say there was a negative here, don't put it here on your calculations. No. All right. So understanding these guys is important, especially in your engineering science. Even if you continue with your mathematics, this understanding of these quadrants is very, very important. It affects most of our engineering science calculations because they will be expecting that you know this from your mathematics. So understanding these guys is going to be important. Just that part of reference angle and the other one, the actual angle. Okay, gonna talk about that. Question 6.3. Let's see. Consider fig 3 below. From a point B on the same horizontal plane as the foot. All right, where is B? Here, from this point B, okay? This is where we are working from. In the same horizontal plane as the foot D. So this is where we have what? Our foot of the tower, all right? So the foot of this tower. The angle of elevation of the top of the tower is 26. Or so from B, it's 26. Then we move a certain distance from C, 800 meters closer to the tower. This one, it is 800 meters closer to the tower. That is 800 at an angle of what? 48. All right, just like that. So this is what we have, this one. Do not worry about that, guys. Already they filled in the information. So let's answer the question. 6.31. Determine AD, the height of the tower. AD, this one, the height of the tower, this one. How can we determine AD? So guys, there we have to figure out according to the information. We just have this 800 only. That's the only side that we have. And it is not even like this. It is not even part of a right angle triangle where we say 800 is part of the right angle to the end there. 800 is a piece from here to here like this. It is not covering the remaining part here. It is not covering here. We do not have this. 800 is here. This one. This is your 800. From B to C. We do not have this one. So it's going to be complicated. Pythagoras theorem cannot be used to calculate any side because we are just given one side at least. Maybe we could have been assisted to calculate a side, then we figure out how to use our angles. So far, in this triangle, there's nothing. This one. In this triangle, there is nothing. So let's figure out about this other triangle. Is if there is anything that we can do. Is there anything that we can do? Let's figure out. We have the 48 degrees. Remember, angles on a straight line, they add up to 180 degrees. So 180 minus 48 was going to be 132 degrees. So this angle here was going to be 132 degrees. We know that angles in a triangle, they add up to 180 degrees. So you can determine the angle which is at A in this triangle. We're talking about inside of the triangle here. You can determine the angle A. So angle A of this triangle, let's just call it what? BAC. So angle BAC is going to be 180 degrees minus these two angles that are inside of the triangle. 26 plus what? 132 degrees. So that was going to give us 22 degrees here. This angle was going to be 22 degrees. There are so many ways, guys, of determining these angles. So what I just want you to see is that we have this triangle here, which also is in contact with the triangle that we need to calculate its length. It is in contact with this triangle. If we can take a closer look. There are two different triangles, but they are in contact. Where are they in contact? Figure out where are they in contact in this case. They are in contact here in this line. AC, this line. They share the same line. So it is either can we calculate this AC, or you can ask yourself, can I calculate this AB? even though it's not a contact line, like direct to say they're in contact, but we can see that it is being shared by the bigger triangle. This one, it has this, it is connected like this one. We can work with AD from that bigger side of AB. We can also work, so this one, what I'm trying to say, guys, AB can give us AD if we apply our trigonometric ratios properly then. Also, AC can give us what? Can give us AD, these two. So can we determine n of these, guys? Can we determine AB? Can we determine AC? So it is up to you. So as for me, guys, I'm just going to work with the AC. It is a little bit closer to our diagram and is also in contact, and we can even understand much better from there. So you can see that AC can be calculated. So we're going to calculate AC first. So this is 6.31. Going to calculate AC first. Why? AC, because it is part of our triangle, and you can use our trigonometric ratios to find AD from there. And how can we find AC? That is the question. How can we determine this? From this a non-right angle triangle, we're just given all the angles. When it is like this, you're supposed to check, is it going to be from the sine rule? This one. Is it going to be from the sine rule, or is it going to be from the cosine rule? Remember, sine rule, it is always an angle corresponding to a side, an angle corresponding to a side. And this is the case that we have. If we check it properly, I want you to see here. If we check properly, sine rule can be used because angle 26 corresponds with the side AC that we want to calculate. They do correspond, these two. All right. The 22 degrees here that we have and this one, they do correspond also. So 132 was going to be limited. We do not have any corresponding side. It was going to be used in, unless if you want to use it to calculate AB. Yes, you can do that. So sine rule, guys, can be used. Sine rule, guys, when you say sine rule, it's simply like this, guys. A over the sine of A is equal to B over the sine of B when you are calculating the side. What does it mean? It simply means, guys, what you are calculating over the sine of its corresponding angle. Do not worry to say, this is my B, this is my what, guys. What is that you're calculating? It's this side here, AC. Write it as it is. So it's AC over the sine of the angle, this AC. What is the angle that is corresponding? It's 26. So it's the sine of that angle, just like that. So it's over sine 26 is equal to B, which is the other part, which is complete. Remember, this is what you want to calculate. And this one is the one that is complete. Which part is that is complete? We say these two. Side on top, the side on top, 800. So that's 800 on top over the sine of what? The angle corresponding to that side. What is the angle there? 22. So it's the sine of 22 degrees. You don't need to actual name. They can give you any letter. They can give you F. They can give you any PQR. You don't need to write sine P over this, guys. Once you know that A over sine A is equal to B over sine B, you're done. When you're calculating angles, make sure that the angles are on top like this. Sine of A over A is equal to, yes, you can use this one to calculate the sides, but it is best that when you're calculating the sides, just write the sides on what? On top. Side over the sine of the angle is equal to side over the sine of that angle corresponding. Side over the sine of the angle is equal to side over sine of the corresponding angle, just like that. So let's calculate our AC, guys. Simply cross multiply AC times sine. That will be AC sine 22 degrees is equal to, you multiply these two, that's 800. The sine of what? The sine of 26 degrees. We want to find AC, so divide by sine what? Sine 22. So this is going to be divided by sine 22, both sides of our equation, so that this can cancel. So that's it. This is our AC. So our AC was going to be what? You simplify the whole of this part as it is. on your calculator, this is you and your calculator, guys. You have your fraction. So remember, I already have fixed my calculator to 3 decimal places. You're going to have your answer to 3 decimal places. Just have a fraction there. Oh, I've already put it. So this is 800 sine 26. Okay, close the bracket to the denominator, sine 22. Right? Why is it dragging now? Sine 22. Okay, sine 22, just like that. So this is it. Since our calculator is to 3 decimal places, we're going to have our answer as 936.174. So that's 936.174 in what? In meters, as we have these other dimensions. We're in what? We're in meters, just like that. So that is how it can be like. So we have AC. From AC, we are going to calculate what? AD. All right. So it's going to be like this. Remember, we needed this to calculate AD. So with our AC, remember I said find AC first. We have it here. This is our AC, 936,174 like this in meters. So how can we calculate AD? Now we can use those trigonometrical ratios, guys. In triangle, ACD, this triangle, this one. So find AD now. So you're gonna find AD. So using triangle ACD, this triangle ACD, guys, we can simply fill in our information using this triangle ACD. We have an angle there. It's a right angle triangle, remember? We have an angle. We want to calculate this side, AD. What does it represent? According to this angle, AD is what? Is the opposite. What about the side that we just calculated, AC? It is the hypotenuse of this one. Yeah, 90 degrees. That is our hypotenuse. So we can use our trigonometrical ratios, guys. Remember your SOHCAHTOA concept, where we have opposite and the hypotenuse at the same time. Opposite and hypotenuse, that's the sign. So the sign of the angle that we are given, 48 degrees, must be equal to opposite over what? Hypotenuse. What is our opposite? AD, the side that we want to calculate. That's our opposite, this one, AD. So it was going to be AD over, that's AD over what? The hypotenuse, which is the side that we calculated, AC. So that's AD over what? AC. So let's substitute, guys, because we have the AC. So sine 48 is equal to AD over AC. This is our AC here, 936,174. So let's calculate our AD. Simply gonna cross multiply. This is over 1. So 1 times AD, this one multiplies this side. All right. So 1 times AD, that's AD, is equal to the product of this. So that's 936,174 times the sine of 48 degrees. As it is on your calculator, you can what? Simplify this. So that was our case, guys. Our AD was going to give us 695,713 in what? In meters, as we saw, guys. We can just use our calculator there. So that is it. We have got AD. So we calculated AC. We calculated AD also. So the question is now on this other part, 6.32, the distance from C to the foot of the tower. Remember, I said this is the foot. But from what? From C. This is where we have C. Yes, we want this distance from C here, this distance. C to the foot of the tower. So there we can use any part, guys, that we understand. You can use your Pythagoras theorem. Remember, we calculated this side here, this one, AD. We have this side, and we also have AD here. So you can use our Pythagoras theorem to calculate the third side, or we can use our trigonometrical ratios. It was up to you on this one. So you can still use your trigonometrical ratios, or you can use your Pythagoras theorem. You put back the side AD that we calculated here. So you put back that AD that we calculated, then use Pythagoras, or you can simply use your ratios. According to this side, I'm going to use this one of 93. You can use any one. And this angle of 48. CD, the side that we want to calculate, is what? The adjacent. We have hypotenuse, AC. AC is the hypotenuse. And CD adjacent. So which ratio from that SOHCAHTOA? That's what? A cos. SOHCAHTOA from a cos. Adjacent over hypotenuse. So the cos of theta, the cos of the angle 48 degrees is equal to the adjacent, which is CD, from C to the foot of the tower. That's the CD. And what is the hypotenuse? Our hypotenuse is what? It's AC, the one that we calculated. So guys, we're simply going to substitute the cos of what? 48 degrees is equal to CD over what? AC. We calculated AC, 936,174. Cross multiply. This is over 1, so you're going to cross multiply just like that. So that's 1 times CD, which is CD, the product of these. So that's 936,174. 174 cos what? Cos 48 degrees, like that. So we can calculate the length of CD from there. We can determine the length of CD. CD is the length from the foot to the tower. This one, that will be our CD. So that was going to give us 626,432. 423 actually, 423 in what? In meters. That's the distance from what? From the foot. So if you check there, the calculation of your Memo, there was actually something there. You can use Pythagoras. Anyone, guys, you can you can use Pythagoras anyway. Anyway, because we have what? Two triangles. I mean, the triangle that has two sides is a right angle triangle. So figure out any other ways that you can apply this and that. Then focusing on 6.4, sketch this graph. If we are to consider, we are being asked to sketch f of x. So that's our 6.4. Our f of x is equal to what? That's 2 cos 2x plus 1 from 0 to 180. The coordinates, or show the coordinates of the turning point and the intercepts with the axis. So I said, guys, whenever you're dealing with a trigonometric function of this nature, if you have this, you can consider this part here, the part of x here. It affects, remember, the graph of a cos as we do understand it. It is like this, guys. This is the graph of a cos. Having a period that is in within what? 360 degrees, it completes its full cycle within 60 degrees. Within 360 degrees, I mean. When it is just like cos x, without any other number, it's just cos x. Coefficient of x is what? It's 1. Once you have a certain number like this one, where there is given 2x, it is going to affect, when it is like this, when it is, let me show you here, guys, when it is something like cos 2x like this one, it simply means your interval will be divided 1. The period also be affected. It was supposed to end at 360. Now it will be 360 divided by this number 2. So it will end at 180 degrees. That's why you see you are being given to 180. So using the normal properties of the graph, it will complete its cycle. This one at 180, that is where it will be completing the full cycle. It will be completing at 180. So it is an adjustment. Everything is adjusted. Even the interval is adjusted. If you are using an interval here of 0 degrees, 90 degrees, 180, 270, this and that, the interval will be affected. If you are using 90, 180 like the steps, you are going to divide each by 2. If it was 90, you divide by 2. So 90 divided by 2, that's 45 degrees. On a normal graph of a cos, this is what you're supposed to have, 90 degrees. The period being what? 360. The same as a graph of what? Of a sine. So whenever you see a number there multiplying, affect it also on your interval, the period, and also the step that you're going to use. So meaning to say on our table, guys, here we are going to divide by what? By 2. Remember, when you have the table for the graph of a cos or the graph of a sine, you were using the 90-degree interval, 0 degrees, 90, and so on. So we are not going to use that. In place of 90, we divide by 2. So it will be at what? 45. When we had got 180 divided by 2, so it's going to be 45, 45. So this one will be 90. 90 plus 45, that's 135. All right, we're still going to need another one. 135 plus 45, that's 180 degrees. So it ends at 180 degrees from 0 to 180. That is where it's going to complete its cycle when it is like this. So guys, substituting these in your calculator as it is, put it as it is like this. All right, let's remove this fix. Let's remove this fix because normally they're going to have all numbers there. All right, so this is it. We need 2 cos. So that is 2 cos. Take note, it's 2x, 2 times the value of x. What is our x? X is what? It's 0. 2 times 0. Whatever that you have, you must close the bracket. This is 2 cos x. Then add a 1 after that. You must add a 1. So our answer was going to be what? A 3. We do the same thing at 45 degrees. Put 45 degrees in place of x. Remember, this is where our x is at that 0 there. So remove this 0 there. All right. Remove that. Put what? 45 degrees. So that's it. We're going to get a 1. So when x is 45, we are going to have y as what? As 1. We do the same thing. 90 degrees. That's another next one. 90 degrees. Remove the 45. We're going to have the 90 degrees here. So this is 90 degrees like this. So that was going to give us -1. The same with the 135 and so on and so on. So going on to the 135 like this, that was going to give us +1. 180. Same thing here, 180 like this. So that was going to give us what? +3, just like that. So guys, with this, we can have our sketches. We can see our graph is being taken from 0 to 180. The step is 45 degrees. So we can have our graph. As you can see, this graph is more positive. It is more positive. So that's our x. And this is our y like this. We've got a 0 here. Let's say this is 45. Okay, I'm not gonna separate that much because the graph, of course, is just complicated, guys. So this is 45, 90, 135, 180 degrees like this. All right. So using the part of y going up, we're gonna have 1, 2, 3, and so on. So that's 1, 2, 3. Okay, that's -1, -2. So we're just limited, guys, from -1 up to +3. -1 is the least. +3 is the maximum. So that's 0 versus 3. We mark our point. 45 versus 1. We mark our point here. 90 versus -1. 135 is now on top. 135 versus 1. 180 versus 3. So it is going to be, guys, this is just a sketch. You must maintain the same shape. Remember the graph of a course, how it looks like, how it is like. So you're just going to have that same concept. The graph of a course is going to be something like this. It's going to pass through this point, 45 degrees, something like that. It have a curve. So at this 90 here, it's a curve here. It's 90 minus 1. There's going to be a curve. Goes to this, something like this. All right. So this is what you're going to have approximately, something like that. So that is your f of x. In that case, your f of x is equal to what? That is 2 into cosine of 2x plus what? Plus 1, like this. So this is how these questions, guys, might be given. Let us continue to revise in light in whatever that we are going to be doing, guys. Trying by all means working out as many questions as we can. That is the major part. So, guys, revisions are very, very important. Very, very important. So that is it. Your graphs there. Turning points can be shown. This point is what? 90 versus -1. There's a turning point there. I mean, this one, maximum value there at 180 versus what? 180 degrees versus 3. Also, this one will be maximum there at 0 versus what? 0 versus 3, just like that. So let's do revise as much as we can, guys, in our revisions, preparations for our tests, and also preparations for the exams, which are ahead of time.